Imagine discovering ice ages ended that completely changes everything we thought we knew about ice age ending. What you're about to see will keep you up tonight. For decades, historians believed the ice simply melted away gradually, leaving no trace of what came before. But hidden in ancient records are details that don't make sense. Maps showing coastlines that shouldn't have been visible. Technical knowledge they shouldn't have. Precision that rivals modern technology. Recent discoveries about ice ages ended revealed something shocking. Beneath Antarctic ice, satellite radar has detected geometric features that look disturbingly artificial. Ancient maps from the 1500s appear to show Antarctica's coastline as it existed thousands of years before it was covered in ice. They knew about things we only discovered centuries later. They mapped structures engineers can't explain. Tonight, I'll show you exactly what they found. I'm covering 15 discoveries about ice age ending that will challenge everything you learned in school. We're talking about drowned continents, lost civilizations, and flood myths that turn out to be true. Number 11 changed how I see ancient civilizations forever. If you're using this to fall asleep, perfect. That's why I make these. So subscribe maybe, and tell me where you're watching from and what time it is. I love seeing different time zones connecting over these ancient mysteries that turn out to be true. Let's start with the most shocking one. Antarctica has always carried with it a silence unlike any other place on Earth. It is a silence so vast, so absolute, that it can swallow the voices of entire civilizations. Stand there on the ice, if you could, and you would hear nothing. No birds crying overhead, no wind rustling through trees, because there are no trees. No distant sounds of human activity, because humans barely exist there. Just the occasional crack of ice shifting under unimaginable weight, and then silence again. Profound, ancient, absolute silence. What if hidden beneath the thick, frozen crust of this immense southern continent, there were echoes of a people long forgotten, perhaps even the very first civilization the world has ever known? The thought unsettles and excites in equal measure. It challenges every neat timeline built by archaeologists and every confident statement about the origins of human culture. It suggests that what we think of as beginnings might instead be fragments written over a deeper story, buried under miles of ice. The earliest explorers of Antarctica never imagined such questions. To them, it was a void at the bottom of the maps, a white emptiness with no story to tell, a place where men could test their courage against nature's indifference, but not a place where history had unfolded. And yet, even in antiquity, there were whispers of a terra australis incognita, an unknown southern land that balanced the world. Greek philosophers debated its existence long before any sail reached the icy waters. Some argued it was essential. If the Earth was a sphere, then surely there had to be a counterweight to the lands of the north. Aristotle himself proposed that symmetry demanded southern continents to balance the known world. What they could not have known was that this idea, born in pure speculation and geometric reasoning, might one day intersect with physical discovery in the most unexpected ways. Antarctica, as we know it today, is the coldest, driest place on Earth. It is a desert, though we rarely think of it that way. Less precipitation falls on Antarctica annually than falls on the Sahara. But instead of sand, there is ice. Ice blankets the continent in layers up to 3 miles thick in some places. pressing down on ancient rock and flattening any clue that life once thrived there. The sheer weight of all that frozen water has actually depressed the bedrock beneath, pushing the continental crust down into the mantle. But scientists have revealed that this frozen wasteland has not always been so. This is not speculation or fringe theory. This is established geological fact. During earlier epochs, Antarctica was lush with forests, rivers, and a climate closer to today's northern Europe, or even milder. Fossilized ferns have been found in rock outcrops near the coast. Petrified wood, turned to stone over millions of years, tells of forests that once grew where now there is only ice and rock. Even dinosaur bones have been unearthed near its coastlines, proving that once upon a time, long before humans existed, warmth and abundant life flourished where today there is only snow and silence. The question that begins to creep in quietly at first is this: if Antarctica was once a habitable landscape covered in forests and crossed by rivers, who or what may have lived there? The standard answer is simple. During the age of dinosaurs, yes, life thrived. But by the time humans evolved, Antarctica had long since frozen over. The ice sheets we see today began forming roughly 34 million years ago during a period called the Oligocene transition, when Earth's climate shifted dramatically and Antarctica's fate was sealed. But here is where the comfortable narrative starts to show cracks. Climate is not static, even over shorter timescales. We know from ice cores drilled deep into the Antarctic ice sheet that the climate has fluctuated significantly even within the last few 100,000 years. There have been warmer periods and colder periods. The question becomes, could any part of Antarctica, perhaps coastal regions, have been ice-free or at least partially habitable within the last 20 or 30,000 years? During a time when humans were already spread across the world, already building shelters, and making art and telling stories. Most historians dismiss such thoughts as imaginative fiction, preferring to keep the origin of complex culture within the safe boundaries of Mesopotamia, Egypt, or the Indus Valley, places where we have clear archaeological evidence. Places where the climate and geography make sense for human settlement. Antarctica fits nowhere in that story. It is a frozen outlier, irrelevant to human history except as a modern curiosity for scientists and adventurers. But there are anomalies that resist such easy dismissal, evidence that doesn't fit the tidy narrative. And these anomalies are not wild speculation from conspiracy theorists. Some come from respected institutions, from maps housed in museums, from satellite data gathered by modern technology. They are small pieces of a puzzle that don't quite fit, and when you start paying attention to them, they whisper uncomfortable questions. One of the most famous of these anomalies is the Piri Reis map, drawn in 1513 by an Ottoman admiral and naval cartographer named Ahmed Muhyiddin Piri. The map is remarkable for several reasons. It shows the coast of South America with surprising accuracy for its time. Centuries before that coastline had been properly surveyed by European explorers. More curiously, the southern portion of the map has been interpreted by some researchers as depicting a portion of Antarctica's coastline, not as it appears today, buried under ice, but as it would appear if the ice were removed. If this interpretation is correct, and it remains hotly debated, the implication is staggering. It would mean that someone, somewhere, charted the continent when its coastline was visible, when it was not covered by ice. And that could only mean one thing, that the map was based on source material that dated back thousands of years to a time before the most recent ice advance, perhaps 10,000 years, perhaps more. Piri Reis himself claimed in notes on the map that he had used older charts as references, including maps from the time of Alexander the Great and even older sources. Was he exaggerating to add prestige to his work? Or was he accurately describing the lineage of the geographical knowledge he had compiled? We may never know for certain, but the fact remains that when modern researchers used satellite technology to map the bedrock beneath Antarctica's ice, some claimed that the coastline revealed matched features shown on the Piri Reis map with uncanny precision. Skeptics point out that such correlations are often overstated, that humans have a tendency to see patterns where none exist, especially when we want to believe in a mystery, that cartographic errors and artistic license could easily account for any apparent similarities. And these are valid cautions. We must be careful not to leap to conclusions based on ambiguous evidence. But to dismiss the question entirely feels premature, because the Piri Reis map is not alone. Other historical maps from the 16th century, including the Orontius Phineus map of 1531 and maps by Gerardus Mercator, show a southern continent in varying degrees of detail. Some of these maps show rivers, mountains, and coastal features in Antarctica that are remarkably consistent with what modern technology has revealed beneath the ice. In the 1960s, a professor of the history of science named Charles Hapgood became fascinated with these old maps. He argued that they represented evidence of an ancient, advanced civilization that had mapped the world in a remote epoch before recorded history. Hapgood's theories were controversial and largely rejected by mainstream academia. But even his critics had to admit that some of the maps he studied showed geographical knowledge that seemed difficult to explain given the technology available at the time they were drawn. To add to this unsettling puzzle, modern satellite studies and ground-penetrating radar have revealed land masses and shapes beneath the ice that defy easy explanation. In some regions, what appears to be natural mountain ridges have been interpreted by enthusiasts as geometric, even pyramidal. The human mind is prone to seeing patterns, especially familiar ones like pyramids or right angles. This is a well-known cognitive bias called pareidolia, the same phenomenon that makes us see faces in clouds or on the surface of Mars. But when symmetry and geometric regularity emerge in places beyond easy human reach, buried under miles of ice, the temptation to wonder becomes irresistible. Could these be natural formations sculpted by ice and erosion, shaped by the immense pressures and flows of glaciers over millions of years? Almost certainly, that is the most likely explanation. But could some of them be the remains of ancient architecture, buried deeper than our history books allow, preserved in frozen silence for thousands upon thousands of years? We have historical precedent for such discoveries. The ruins of Troy were once dismissed as nothing more than legend, the fantasy of Homer's epic poems. But a determined and somewhat obsessive archaeologist named Heinrich Schliemann dug them up from beneath layers of soil in the 19th century, proving that the city had been real all along. The lost cities of Central America, the great Mayan and Aztec complexes, lay concealed under jungle canopy until modern explorers cleared the vines and revealed stone pyramids and plazas that had been swallowed by vegetation. Is it truly impossible to imagine that another such discovery might lie under Antarctic ice, preserved by the very forces that conceal it? Preserved not by jungle or sand, but by cold so extreme that it acts like a time capsule, keeping everything exactly as it was when the ice first covered it. This is not merely a question of curiosity or an intellectual exercise. If such a civilization existed, if human beings or their close ancestors built structures and created culture in Antarctica during a warmer period, it would fundamentally alter the story of humanity's development. It would imply that complex societies may have emerged far earlier than we currently believe, that humans or proto-humans may have adapted to and thrived in climates we do not associate with the origins of civilization. It would push back the clock on when humans began building, planning, creating on a large scale. It would also confront us with an uncomfortable idea that our current civilization, with all its confidence and technological sophistication, may not be the first to rise to a global or near global scale, that there may have been others before us, now lost to time and ice and rising seas. And if there were others before us, if they rose and then fell, what does that say about the permanence of what we are building now? In recent years, the scientific community has contributed findings that fuel this speculation, even if unintentionally. Ice core samples taken from deep within the Antarctic ice sheet have revealed not just climatic fluctuations, but hints of sudden cataclysmic events. Layers of ash trapped within the ice point to violent volcanic eruptions, possibly from Antarctic volcanoes we know exist beneath the ice. Sharp chemical signatures suggest meteorite impacts or cosmic dust influxes, evidence of extraterrestrial material raining down on Earth during specific periods. These align with theories of abrupt climate change, events which could transform a fertile land into a frozen wilderness within a geological blink of an eye. If humans lived there during a warmer interlude, their world could have been erased nearly overnight. Not through gradual cooling, but through sudden catastrophe, a volcanic eruption darkening the skies, a meteorite impact triggering rapid climate shifts. Within a generation or two, green lands could become ice, and any people living there would have had to flee or perish. Those who escaped might have carried stories with them, memories of a lost homeland in the far south. And those stories might have been passed down through generations, eventually becoming myths. Myths that we, in our modern arrogance, dismiss as mere fiction. Outside of hard science, myths and oral traditions from around the world add strange voices to this conversation. Tales of lost southern lands are told in Polynesia, South America, and even ancient Greece. These stories seem oddly out of place unless they carried some shadow of reality, some distant echo of actual events. Some researchers suggest that myths may preserve distant cultural memories of migrations, of islands or even continents that were swallowed by ice or by the rising ocean that came when the ice melted. Others caution against such leaps, pointing out how often myths blend imagination and reality in ways that make them unreliable as historical sources. A flood story, for example, might reflect a local river flooding, a tsunami, or simply the universal human fear of water as a destructive force. It doesn't necessarily mean a global deluge or the drowning of continents. Yet the convergence of stories from opposite ends of the earth raises at least the possibility of a shared memory. a memory of something lost, something that once was and is no more. And if Antarctica truly was habitable in the not too distant past, if people lived there and then were forced to abandon it as the ice returned, then perhaps some fragment of that story survived, passed down in oral traditions, encoded in myths, hinted at in ancient maps. The silence of Antarctica holds its secrets tightly. We have barely scratched the surface, quite literally. Most of the continent remains unexplored in any detailed way. The ice is too thick, the conditions too harsh, the expense too great to mount comprehensive archaeological surveys beneath the ice. And so we are left with questions. Tantalizing, frustrating, profound questions. What lies beneath the ice? Are there mountains and valleys we have never seen? Are there features carved by ancient rivers, shaped by forests, perhaps even altered by human hands? Or is there nothing but rock and ice and the slow grinding of geological processes indifferent to human curiosity? We may not know the answers in our lifetimes, but the questions themselves change how we think about history. They remind us that the past is not a settled matter, not a closed book. Every decade brings new discoveries that overturn old certainties. Göbekli Tepe in Turkey, discovered in the 1990s, showed that humans were building massive stone temples 11,000 years ago, long before they were supposed to have the organization or motivation for such projects. Underwater archaeology off the coasts of India and Japan has revealed structures that suggest human habitation in areas now submerged by rising seas. The world is larger and older and stranger than we often admit. And Antarctica, silent and frozen at the bottom of the world, stands as a reminder that there are places we have not looked, questions we have not asked, stories we have not yet heard. To understand what might be hidden there, to understand whether the maps and myths point to something real, we must first understand the world as it was. We must travel back in time, not just a few centuries or even a few millennia, but tens of thousands of years, back to a time when the world looked nothing like it does today. When ice covered much of the northern hemisphere, and when the lands we now see as ocean were dry ground where people walked, hunted, and lived. We must understand the Ice Age, and we must understand how it ended, because it is in that ending, in the great thaw and the catastrophic changes that followed, that the answer to Antarctica's mystery may lie. The Ice Ages ended, and when they did, everything changed. The world that was... Imagine Earth 20,000 years ago, not as an abstract concept, but as a living, breathing world that you could walk through if time travel were possible. Close your eyes for a moment and picture it. The year is 18,000 BCE, give or take a few centuries. This is the period geologists call the last glacial maximum, the peak of the most recent ice age. The coldest, most frozen Earth has been in the entire span of human existence. If you were to look at our planet from space during this time, it would appear dramatically different from the blue and green marble we know today. Vast sheets of ice, miles thick in places, cover enormous portions of the northern hemisphere. All of Canada buried under ice. The northern United States, down to where New York and Chicago would one day stand, under glaciers. Scandinavia, Britain, Northern Europe, all encased in frozen whiteness. Ice extending south to where Berlin and London will eventually rise, grinding slowly over the landscape, carving valleys and scraping bedrock. In total, roughly 1/3 of Earth's land surface is covered by ice sheets. Not just seasonal snow that melts in summer, but permanent, year-round ice that has accumulated over thousands of years, layer upon frozen layer, compressing into dense glacial ice that flows like slow motion liquid under its own immense weight. But the ice sheets are only part of the story. The truly profound difference, the change that would reshape the map of the world, is what happened to the oceans. Water that would normally be in the seas has been locked up in those massive ice sheets, evaporated from the oceans, fallen as snow, and frozen in place on land. And because so much water is trapped as ice, sea levels around the world are dramatically lower than they are today. How much lower? Modern geological and oceanographic studies give us a precise answer: approximately 120 meters lower than present sea levels. That's nearly 400 feet. To put that in perspective, imagine a 40-story building. Now imagine that the ocean surface you see today was at the top of that building, and during the Ice Age, it was at ground level. The difference is staggering. This drop in sea level exposed vast areas of the continental shelves, the shallow underwater margins of the continents. Land that today lies beneath waves was dry ground, and because continental shelves tend to be relatively flat and nutrient-rich, this newly exposed land would have been prime territory for both animals and humans. Coastal plains stretching for miles, river valleys extending far beyond their current mouths, islands connecting into continuous landmasses. Let's take a tour of this transformed world, region by region, and see what it looked like. In North America, the Bering Strait, which today separates Alaska from Siberia with about 50 miles of cold ocean, did not exist. Instead, there was Beringia, a vast landmass connecting Asia to North America. Not just a narrow bridge, but an expanse of tundra and grassland roughly 1,000 miles wide from north to south. Beringia was not a barren wasteland. It was a cold but habitable environment, home to mammoths, bison, horses, and the humans who hunted them. It was across this land that the first people migrated from Asia into the Americas, though exactly when and how remains a subject of ongoing research and debate. In Europe, Britain was not an island. The English Channel did not exist. Instead, there was Doggerland, a low-lying landscape connecting Britain to continental Europe. Doggerland was roughly the size of Britain itself, an area of about 100,000 square miles. It was crossed by rivers, dotted with lakes, covered in forests and grasslands. Archaeological evidence, pulled up by fishing trawlers over the years, shows that Doggerland was inhabited. People lived there, hunted there, made tools there. It was prime real estate during the Ice Age, and it would remain so until the ice melted and the seas rose to claim it. Move south and east to the Mediterranean, and you would find that it too was different. Sea levels lower by 100 meters meant that many islands were larger. Some were connected to the mainland, and coastal areas extended far beyond their current boundaries. The Adriatic Sea was much smaller. You could walk across what is now the northern Adriatic from Italy to Croatia. The Aegean had more land exposed, with many islands forming a nearly continuous bridge between Greece and Turkey. Continue east to the Persian Gulf, and you would find something remarkable. It didn't exist as a body of water. The Gulf was a river valley, a fertile lowland watered by the Tigris and Euphrates rivers, which flowed together through this valley and eventually emptied into the ocean much farther south than they do today. This region, now underwater, may have been lush and heavily populated. Some researchers have even speculated that it could be the geographical basis for the Garden of Eden myth, a fertile paradise lost beneath the waves when the seas rose. In Southeast Asia, the transformation is even more dramatic. Today, Indonesia, Malaysia, and the Philippines are thousands of islands scattered across tropical seas. But during the Ice Age, most of these islands were connected into a single landmass called Sundaland. Borneo, Sumatra, Java, and the Malay Peninsula were all part of one continuous land. Sundaland was enormous, roughly the size of Western Europe. It would have had diverse ecosystems, from tropical rainforests to coastal plains, and it would have been inhabited by both animals and humans. Why does this matter? Because if Sundaland was inhabited, if people lived there for thousands of years, developing cultures and technologies, then all evidence of that would now be underwater. When the ice melted and the seas rose, Sundaland drowned. Any cities, monuments, or villages built on its lowlands would have been swallowed by the sea. The epicenter of a potential ancient civilization lost beneath the shallow waters of the South China Sea, the Java Sea, and the Gulf of Thailand. The same pattern repeats around the world. In the Arctic, much of the Siberian shelf was exposed, extending the coastline hundreds of miles north of where it is today. In Australia, the continent was larger, connected to Tasmania in the south, and nearly connected to New Guinea in the north. What is now the Torres Strait and the Bass Strait were land. Off the coast of India, sea levels were lower, exposing more of the western continental shelf and creating a different coastline. Ancient port cities, if they existed on what was then the coast, would now be many miles offshore and underwater. The coastline of Africa was different, with more land exposed, particularly along the shallow shelves off the west and south coasts. In South America, the Atlantic coastline extended farther east, and the Caribbean was a smaller, shallower sea with more islands and land bridges. All told, the total amount of land exposed during the last glacial maximum was roughly 20 million square kilometers more than today. That's an area larger than Russia. Land that is now ocean floor was once open to the sky, available for animals and humans to occupy, hunt, and live on. And people did live on much of this land, because here's the crucial point: 20,000 years ago, humans were already widespread across the globe. We tend to think of early humans as primitive and rare, scattered in small bands, barely surviving. But by the time of the last glacial maximum, Homo sapiens had already migrated out of Africa, spread across Europe, Asia, and into Australia. We had developed sophisticated tools, clothing, shelter. We had art, jewelry, complex social structures. We were not primitives cowering in caves. We were adaptable, intelligent survivors who had figured out how to live in nearly every environment Earth offered. And where did most humans live? The same place most humans live today, near the coasts. Coastal areas provide the richest and most reliable food sources: fish, shellfish, marine mammals, seabirds, and the land animals that come to the coasts to feed. Rivers meet the sea, providing fresh water. Coastal plains offer flat, easy terrain compared to mountains or dense forests. If most humans during the Ice Age lived near the coasts, then most of their settlements, their campsites, their early villages were on land that is now underwater. When the ice melted and sea levels rose by 120 meters, all that evidence was drowned. The archaeological record of coastal, dwelling Ice Age humans is almost entirely gone, submerged beneath the continental shelves. This is not speculation. This is a straightforward consequence of sea level change, and it means that our understanding of Ice Age human cultures is necessarily incomplete. We are seeing only the inland populations, the ones who lived in caves and highlands. We are missing the coastal peoples who may have been more numerous, more developed, more sophisticated. It's as if we were trying to understand modern human civilization, but could only study communities living in mountains and deserts, while all the coastal cities were invisible to us. The climate during the last glacial maximum was also dramatically different from today. Global average temperatures were about 5 to 6 degrees Celsius colder than now. That might not sound like much, but small shifts in average temperature have enormous effects on climate systems. Much of the world was drier because so much water was locked up as ice. The tropics were cooler and less humid. The temperate zones were colder and harsher, and vast areas that are now forested or agricultural were tundra or cold grassland. But it wasn't uniformly bleak. Some areas that are now harsh deserts were actually more habitable during the Ice Age. The Sahara, for example, went through periods of being wetter and greener during and between ice ages, with lakes and rivers and grasslands, where now there is only sand. Human populations moved with these climate shifts, following the resources, adapting to the changing world. And what about Antarctica? During this same period, while the northern hemisphere was buried under ice, Antarctica remained frozen as it had been for millions of years. Or did it? Here's where the question gets interesting. Antarctica's ice sheet is ancient, yes, but ice sheets are not static. They grow and shrink with climate changes. During colder periods, they expand. During warmer periods, they retreat. Even during the last glacial maximum, when much of the northern hemisphere was frozen, Antarctica's climate would have been affected too, though in complex ways. Some researchers have proposed that parts of Antarctica, particularly coastal areas, might have had less ice cover during certain periods. That glacial dynamics in the southern hemisphere did not perfectly mirror those in the north. That there could have been windows of opportunity, brief warming periods, or regional variations when parts of Antarctica's coastline were accessible. This is speculative, and most glaciologists would say that any ice-free periods in Antarctica during the time humans existed would have been minimal and brief. But the possibility exists. And if the Piri Reis map and others like it truly do show Antarctica's coastline as it appears beneath the ice, then that knowledge had to come from a time when it was visible, which means either these maps are coincidences or someone, at some point in the deep past, saw and charted Antarctica's coast. The world of 20,000 years ago was a world of ice and low seas, a world where continents were connected and coastlines extended far beyond their current reach. A world where megafauna, the great beasts of the Pleistocene, roamed in vast numbers. Woolly mammoths and mastodons in the north, giant ground sloths and glyptodons in South America, megafauna kangaroos and diprotodons in Australia, cave lions, cave bears, woolly rhinoceroses, saber-toothed cats. The earth teemed with giants. And among these giants, humans moved and hunted and survived. We were not the dominant species. We were clever, adaptable, dangerous in groups, but still just one predator among many. The idea that humans would eventually outlive all these great beasts, that we would spread to every corner of the globe and transform the planet itself, would have seemed impossible. But we did, and the transformation began with the end of the Ice Age. Because the ice could not last forever. Earth's climate cycles, driven by variations in the planet's orbit and tilt, ensured that ice ages come and go, and 20,000 years ago, the cycle was about to turn. The ice that had ruled the world for 100,000 years was about to melt. The seas that had retreated were about to rise. And the world that was the world of exposed continents and land bridges and coastal plains was about to be drowned. But someone may have been mapping this world before it disappeared. Someone may have known the coastlines, charted the rivers, recorded the geography of a world that would soon be lost. And if that knowledge was preserved, passed down through generations, copied from ancient source maps onto newer parchments, then perhaps the maps we see today, the maps that shouldn't show what they show, are echoes of that lost knowledge. To understand if this is possible, to understand whether there could have been a civilization advanced enough to map the world before the ice melted and the seas rose, we need to look more closely at the evidence. We need to examine these mysterious maps. We need to ask whether they truly show what their interpreters claim, and we need to consider what it would mean if they do. Maps that shouldn't exist in 1929. A group of scholars working in the Topkapi Palace in Istanbul made a discovery that would puzzle researchers for decades to come. Hidden among a collection of old documents and maps, they found a partial map drawn on gazelle skin parchment. The map was dated to the year 1513 and bore the signature and seal of an Ottoman admiral named Piri Reis, who was also a renowned cartographer and geographer of his time. The Piri Reis map shows the western coast of Africa, the eastern coast of South America, and extends southward to what appears to be a coastline at the bottom of the known world. At first glance, it's a beautifully illustrated example of 16th century cartography, decorated with images of ships, sea monsters, and exotic animals. But when researchers began studying it more closely, they found details that didn't quite make sense. Details that sparked a debate that continues to this day. Piri Reis himself left notes on the map explaining how he created it. He wrote that he had compiled his map from about 20 source charts and maps, some of which were very ancient. He specifically mentioned using maps captured from Spanish sailors, maps dating back to the time of Alexander the Great, and even older sources. He claimed that these ancient maps had been preserved and passed down through generations of navigators and scholars. Now, such claims were not unusual for cartographers of that era. Mapmakers often exaggerated the age and importance of their sources to add prestige to their work. So historians initially took Piri Reis's claims with a healthy dose of skepticism, but then they started examining the map's geographical details. And that's when things got interesting. The depiction of South America on the Piri Reis map is surprisingly accurate for 1513. Columbus had only reached the Caribbean and the northern coast of South America. The Portuguese and Spanish were just beginning to explore the continent. Comprehensive surveys of the South American coastline wouldn't happen for decades. Yet the Piri Reis map shows the eastern coastline of South America, including the mouth of the Amazon River, with remarkable accuracy, more accurate in some respects than maps that would be produced 20 or 30 years later. How did Piri Reis achieve this accuracy? The most likely explanation is that he did indeed have access to recent Spanish and Portuguese charts based on early explorations, combined with his own knowledge and intelligent guesswork. But it's the southern portion of the map that has generated the most controversy and speculation. The map extends south beyond South America to show a large landmass at the bottom. For centuries, this landmass was assumed to be an exaggerated or speculative depiction of South America's southern tip, perhaps Tierra del Fuego, or simply the kind of mythical land that mapmakers of the era often included to fill empty spaces. But in 1956, a professor named Charles Hapgood began to look at the map with fresh eyes. Hapgood was a professor of the history of science at Keene State College in New Hampshire. He was fascinated by ancient maps and what they might reveal about the geographical knowledge of earlier civilizations. When he studied the Piri Reis map, he came to a startling conclusion. He believed the southern landmass depicted on the map was not South America at all, but Antarctica. More specifically, Antarctica, as it would appear if the ice were removed, showing the actual coastline of the continent beneath. Hapgood's theory was based on several observations. First, the shape and position of the landmass, when properly oriented and scaled, seemed to match the coast of Queen Maud Land in Antarctica. Second, the map showed mountains in this southern land, which would correspond to the Transantarctic mountain range. Third, and most intriguingly, the coastline depicted appeared to match not the ice-covered coast of Antarctica, but the bedrock coastline that lies beneath the ice. Hapgood published his findings in a book called Maps of the Ancient Sea Kings in 1966. He argued that the Piri Reis map, along with several other historical maps, contained geographical knowledge that could only have come from a time before Antarctica was completely ice-covered. He proposed that an advanced ancient civilization, possibly dating back to the end of the last ice age, had mapped the world including Antarctica. This knowledge was then preserved and passed down through the ages, eventually finding its way onto medieval and Renaissance maps. The reaction from the academic community was, predictably, skeptical. Most historians and cartographers rejected Hapgood's interpretation. They pointed out several problems with his theory. First, the match between the Piri Reis map and Antarctica's coastline was not as precise as Hapgood claimed. It required significant stretching, rotating, and selective interpretation to make the correlation work. Different researchers, using different methods, came up with different results, some showing good matches and others showing none at all. Second, the projection and scale of the Piri Reis map are inconsistent and distorted, as was common with early maps. Trying to match it precisely to modern geographical data is problematic because the map itself doesn't use a consistent mathematical projection. It's a compilation of different sources, each with its own errors and distortions, stitched together by Piri Reis in a way that made sense to him but doesn't correspond to any standard cartographic system. Third, and perhaps most importantly, there is no historical evidence of any civilization having the capability to explore and map Antarctica in ancient times. No archaeological remains, no artifacts, no written records. The idea that such a civilization existed, accomplished this feat, and then vanished completely, leaving almost no trace, strikes most scholars as far-fetched. But Hapgood's theory caught the public imagination. It offered a tantalizing mystery, a hint that our ancestors might have known more than we give them credit for. And while mainstream academia largely dismissed his work, some researchers have continued to find the map intriguing. In the decades since Hapgood, new technology has allowed for more detailed analysis. Satellite radar mapping of Antarctica, which can penetrate through the ice to image the bedrock beneath, has given us an accurate picture of what Antarctica's coastline actually looks like under the ice. Some researchers have compared these modern data to the Piri-Reis map and claim to find remarkable similarities. Others have done the same analysis and found no compelling match. The debate continues with no clear consensus. But the Piri-Reis map is not alone. There are other historical maps that show similar anomalies. The Orontius Phineus map from 1531 also shows a southern continent with remarkable detail. This map depicts a landmass identified as Terra Australis, with rivers, mountains, and coastal features. The shape and size bear some resemblance to Antarctica, though again, the match is not perfect and is subject to interpretation. The Mercator map of 1569 shows Antarctica as a large southern continent, though by this time the existence of such a continent was widely theorized, even if no one had seen it. What's more interesting is that some of the earlier source maps that Mercator may have used show even more detail, suggesting he was working from older traditions of geographical knowledge. Philip Buch, a French geographer, produced a map in 1737 that shows Antarctica divided into two large islands by a channel of water. Modern seismic surveys have revealed that beneath the ice, Antarctica is indeed divided by a subglacial channel that would, if the ice were removed, separate the continent into two major landmasses. How could Buch have known this in 1737? He claimed to be working from older maps, though he didn't specify how old or where they came from. Taken individually, each of these maps can be explained away as coincidence, artistic interpretation, lucky guesses, or the incorporation of theoretical geography based on the classical idea that a southern continent must exist for balance. But taken together, they form a pattern that some find difficult to dismiss entirely. A pattern suggesting that somewhere in the deep past, someone had more accurate geographical knowledge than the official historical narrative allows for. Charles Hapgood proposed a radical explanation that the Earth's crust could shift over the mantle in relatively short geological time periods, a theory called crustal displacement or Earth crust displacement. He suggested that Antarctica might have been in a more temperate location in the relatively recent past, perhaps 12,000 years ago, and then shifted to its current polar position. This would explain how it could have been mapped when ice, free. However, this theory has been thoroughly rejected by modern geology. The evidence for plate tectonics is overwhelming, and crustal displacement of the type Hapgood proposed simply doesn't fit the data. Without crustal displacement, we're left with the question if these maps do show Antarctica, when and how was it mapped? The only way Antarctica's bedrock coastline could have been visible and accessible for mapping is if it was less ice covered than it is today. And the only time in recent geological history when that might have been possible is during or shortly after the last ice age, when global climates were in flux. Could a civilization have existed with the maritime technology to explore and chart Antarctica 10,000 or 15,000 years ago? This pushes against everything we think we know about human development. The standard archaeological timeline has humans living as hunter-gatherers until about 10,000 years ago, when agriculture began to develop in the Fertile Crescent. Complex civilizations with writing cities and advanced technology don't emerge until much later, around 5,000 to 6,000 years ago in Mesopotamia and Egypt. But what if the standard timeline is incomplete? What if there were advanced cultures during the Ice Age that we simply haven't found evidence for yet, because their remains are underwater or under ice? This is the question that researchers like Graham Hancock have raised. Hancock, in books like Fingerprints of the Gods and Magicians of the Gods, has argued that there was an advanced civilization during the Ice Age that was largely destroyed by the climate catastrophes at the end of the Younger Dryas period, around 11,700 years ago. Hancock and others point to sites like Göbekli Tepe in Turkey, which dates to about 11,600 years ago and shows a level of organization and architectural sophistication that wasn't supposed to exist among hunter-gatherer populations. If hunter-gatherers could build Göbekli Tepe, what else might they have been capable of? Could there have been maritime cultures that explored extensively, developed navigation and map-making skills, and left records that survived in some form? The mainstream archaeological community is skeptical, to put it mildly. The lack of physical evidence is a major problem. Where are the ships? Where are the tools? Where are the settlements? If a civilization advanced enough to map Antarctica existed, it would have left traces. And while it's true that much potential evidence might be underwater or under ice, the complete absence of any confirmed artifacts is hard to explain. Moreover, mapmaking requires not just the ability to travel and observe, but also mathematical sophistication to create accurate projections and scales. It requires understanding of latitude and longitude, or at least some system for representing three-dimensional geography on a two-dimensional surface. These are not simple skills. They represent a high level of intellectual and technical development. However, there's an interesting counter-argument. Indigenous peoples around the world, including Polynesian navigators, Australian Aboriginals, and Arctic Inuit, had sophisticated geographical knowledge of their regions, transmitted orally and through memory rather than written maps. Polynesian navigators crossed thousands of miles of open ocean using mental maps based on stars, currents, swells, and bird migration patterns. They didn't need paper maps to find their way. Could ancient mariners have had similar skills? And could that knowledge have eventually been transcribed onto maps by later civilizations? This is possible, but it still requires that someone, at some point, actually traveled to and observed Antarctica's coastline. And that observation had to happen when the coastline was visible, which brings us back to the same chronological problem. If Antarctica has been fully ice, covered for millions of years, as most geologists believe, then no amount of ancient seafaring could have produced maps of its bedrock coast. The only way out of this dilemma is to argue that parts of Antarctica were less ice, covered more recently than current models suggest, which is a minority position in glaciology, but not entirely impossible. There's also the possibility that the whole thing is a misinterpretation, that the landmasses on these old maps are not Antarctica at all, but something else. Distorted versions of South America, or purely imaginary continents drawn to fill the unknown southern hemisphere, or compilations of confused reports from various explorers. Human pattern recognition is powerful, and we often see what we expect or want to see. The same phenomenon that makes people see faces on Mars or religious figures in toast might be at work when researchers look at old maps and see Antarctica. And yet, the question refuses to die. The Piri Reis map continues to fascinate. New researchers continue to study it, applying new techniques and analyses. Some find correlations that support ancient knowledge. Others find nothing but coincidence. The debate remains unresolved. What can we say with certainty? The Piri Reis map exists. It does show a southern landmass with some features that could, with interpretation, match Antarctica. Piri Reis did claim to use ancient sources, and Antarctica does exist beneath its ice, with a coastline that would be accessible if the ice were removed. Whether these facts connect in the way Hapgood and others have suggested, or whether they're simply coincidences and misinterpretations, remains an open question. The map is a Rorschach test of sorts. Skeptics see a 16th century map with typical errors and artistic liberties. Believers see evidence of lost knowledge from a vanished civilization. And the truth, as is often the case, may lie somewhere in between. Perhaps not proof of an Ice Age civilization mapping Antarctica, but perhaps hints that ancient peoples knew more about the world than we've assumed. That knowledge, exploration, and geographical understanding extend further back than the written record allows us to see clearly. The maps that shouldn't exist, if they truly are what some claim, would require us to rethink human history in fundamental ways. They would push the timeline of advanced civilization back by thousands of years. They would suggest that the end of the Ice Age destroyed not just a way of life, but perhaps entire civilizations, leaving only fragments and echoes. And they would mean that Antarctica, silent and frozen, holds secrets not just of geological history, but of human history as well. Secrets buried so deep under ice that we may never fully uncover them, left only with these puzzling maps as tantalizing clues to a past we can barely imagine. The Great Freezing, to understand when Antarctica could have been accessible for mapping, we need to understand the story of how and when it became the frozen continent we know today. This is not a simple story. It spans millions of years and involves complex interactions between Earth's climate, its orbit around the Sun, and the slow movements of continents across the planet's surface. But if we're patient, if we take our time and let the story unfold, we can begin to see how Antarctica transformed from a green land into the ice-locked wasteland it is today. Go back far enough, hundreds of millions of years, and Antarctica was unrecognizable. It was part of the supercontinent Gondwana, joined with South America, Africa, India, Australia, and other landmasses. It sat not at the South Pole, but in more temperate latitudes. And it was warm, lush. Forests covered its landscapes. Rivers carved valleys through ancient rocks. Animals moved through its environments, adapted to warmth and plenty rather than cold and scarcity. We know this from the geological record, from fossils found in Antarctica's rocks, coal deposits that formed from ancient swamp forests, fossilized leaves, wood, and even dinosaur bones. Antarctica was once a place where life flourished on a scale that would be impossible today, where the sun's warmth reached the land for much of the year, where rain fell and nourished ecosystems as complex as those found anywhere else on Earth. But continents move. This is one of the great discoveries of 20th century geology, the theory of plate tectonics. Earth's surface is divided into large plates of solid rock that float, in a sense, on the semi-molten mantle beneath. These plates move slowly, just a few centimeters per year, but over millions of years, those small movements add up to dramatic changes. Continents drift, oceans open and close, mountains rise and erode. And so Antarctica, over tens of millions of years, drifted south. The supercontinent Gondwana broke apart. South America moved west. Africa moved north. India collided with Asia, pushing up the Himalayas. Australia drifted northeast. And Antarctica, almost alone, moved toward the South Pole, eventually centering itself over the bottom of the world. This southward drift had profound consequences, because once Antarctica reached high southern latitudes, once it centered itself over the pole, it began to cool. The sun's rays, striking at ever more oblique angles, provided less warmth. Winters became longer and colder. Snow that fell in winter no longer fully melted in summer. Year by year, the snow accumulated, compressed into ice, spread outward in glaciers that carved the landscape and pushed toward the coasts. The timing of Antarctica's glaciation is complex and not fully settled among scientists, but the broad outlines are clear. Antarctica began its journey south starting around 180 million years ago, when Gondwana began to break up. But it remained relatively warm, with temperate or even sub-tropical climates for much of the subsequent period. As late as 50 or 60 million years ago, during the Eocene epoch, Antarctica still had forests, possibly even palm trees in some coastal regions during warmer periods. The climate was cooling, yes, but slowly. The major freeze began about 34 million years ago, during what's called the Eocene-Oligocene transition. This was a period of rapid global cooling triggered by several factors. One major factor was the opening of the Drake Passage, the body of water between Antarctica and South America. When this seaway fully opened, it allowed the development of the Antarctic Circumpolar Current, a powerful ocean current that circles Antarctica from west to east, effectively isolating the continent from warmer waters to the north. Before the circumpolar current existed, ocean currents brought relatively warm water from lower latitudes to Antarctica's shores, moderating its climate. But once the current formed, it acted like a thermal barrier. Antarctica was cut off from the warming influence of tropical and subtropical oceans. The continent began to cool rapidly. Snow accumulated faster. Glaciers formed and grew. And within a relatively short geological time, perhaps just a few 100,000 years, Antarctica transformed from a partially forested land into an ice-covered continent. This ice didn't just sit there, it grew, it spread, it thickened. Over millions of years, the ice sheet expanded to cover nearly the entire continent. In places, the ice reached thicknesses of 3 miles or more. The weight of this ice was so immense that it pushed the bedrock beneath it down, depressing the continental crust into the mantle. And once this ice was established, it became self-reinforcing. Ice is white, which means it reflects sunlight rather than absorbing it. This increases cooling. More ice leads to more reflectivity, which leads to more cooling, which leads to more ice. This is called the ice albedo feedback, and it's one reason why ice ages, once started, tend to persist. So by about 34 million years ago, Antarctica had its ice sheet, and that ice sheet has persisted in one form or another ever since, through the Oligocene, the Miocene, the Pliocene, and into the Pleistocene epoch that we're still technically in today. For 34 million years, Antarctica has been frozen. But, and this is a crucial but, frozen doesn't mean unchanging. Even though the ice sheet has persisted for millions of years, it has grown and shrunk with changes in global climate. During colder periods, the ice advances, thickening and spreading farther out from the continent's center. During warmer periods, the ice retreats, thinning and pulling back. These fluctuations are driven by cyclical changes in Earth's orbit and tilt, known as Milankovitch cycles. Every 100 zoosine years or so, Earth's orbit becomes more or less elliptical. Every 41 zousine years, the tilt of Earth's axis shifts slightly. Every 26,000 years, the direction Earth's axis points wobbles like a spinning top. These changes affect how much solar energy different parts of Earth receive during different seasons. And these changes, small as they seem, are enough to trigger ice ages and warm periods. For the last few million years, Earth has been in an ice age in the broad sense, meaning there are permanent ice sheets at the poles. But within this ice age, there have been glacial and interglacial periods. During glacials, ice sheets advance over North America and Europe, as well as growing in Antarctica. During interglacials, those ice sheets retreat. We are currently in an interglacial period called the Holocene, which began about 11,700 years ago. The key question for our purposes is, during these fluctuations, did parts of Antarctica ever become ice free? Specifically, did coastal regions ever become accessible during warmer periods within the last few 100,000 years when humans already existed? The mainstream scientific answer is probably not significantly. While the Antarctic ice sheet has certainly fluctuated in size, with the ice edge advancing and retreating over time, the consensus is that the continent has remained mostly ice, covered for millions of years. During warmer interglacial periods, some coastal areas might have had less ice, and there might have been ice-free valleys in some mountain regions. But the idea of large areas of Antarctica being ice-free and accessible for exploration during the time humans have existed is not supported by most glaciologists. However, this consensus is based on the best available evidence and models, which have limitations. Ice core records go back 800 zoosine years, which is a long time from a human perspective, but just a small fraction of the time Antarctica has been frozen. Geological evidence from coastal regions is limited because, well, most of it is under ice, and there are ongoing debates about exactly how stable the Antarctic ice sheet has been even in relatively recent times. Some researchers have proposed that during particularly warm interglacial periods, parts of the West Antarctic ice sheet, which sits on bedrock below sea level, might have collapsed more dramatically than previously thought, potentially exposing coastal regions. This is controversial and not widely accepted, but it's not completely impossible either. There's also the question of whether humans, or their ancestors, could have reached Antarctica even if parts of it were less ice covered. The Southern Ocean is treacherous, cold, stormy, full of icebergs and pack ice. Crossing it requires seaworthy boats and navigation skills. We know that ancient humans were capable sailors. Humans reached Australia at least 65 zousine years ago, which required ocean crossings. Polynesians settled remote Pacific islands using outrigger canoes and remarkable navigation knowledge. So the idea that ancient mariners could have reached Antarctica isn't completely absurd if they had a reason to go there and if the climate at the time made it possible. But here's the problem with the timeline. If Antarctica's ice sheet has been essentially stable and comprehensive for millions of years, as most geologists believe, then no amount of ancient seafaring could have resulted in maps of ice-free Antarctica. The coastline they would have seen would have been ice, not rock. The only way to map the bedrock coastline is if the ice wasn't there. This brings us back to the Piri Reis map and others like it. If they do show Antarctica's bedrock coastline, as some claim, then either one, the match is coincidental. The map shows something else, and we're seeing patterns that aren't really there. 2. The map was based on very ancient knowledge from a time when parts of Antarctica were less ice, covered, but this would push the date back millions of years, long before humans existed in any form we'd recognize. 3. Parts of Antarctica were less ice, covered more recently than mainstream science currently accepts, perhaps during an unusually warm interglacial period in the last few 100,000 years, and ancient humans somehow reached it and mapped it. 4. The maps show not reality, but speculation. Ancient geographers, knowing that a southern continent must exist for balance, as the Greeks theorized, drew in details based on logical guesses or mythological traditions rather than actual observation. Most scientists lean toward options 1 and 4. The maps are either misinterpreted coincidences or speculative geography, not evidence of actual ancient exploration of Antarctica. But the debate continues because the question remains tantalizing. The coincidences, if that's what they are remarkable, and our knowledge of Earth's climate history, while extensive, is not complete. What we can say with confidence is this: Antarctica is ancient and frozen. It has been frozen for a very long time. Any period of significant ice-free coastline would have been millions of years before humans existed. Unless there's something we've missed, some warm period, more recent than we realize, some mechanism for ice retreat that we haven't fully accounted for. The ice cores tell us a story. The deepest ice cores drilled in Antarctica go back 800,000 years, capturing air bubbles and particles that preserve a record of past climates. These records show fluctuations, yes, warmer and colder periods, but they don't show Antarctica completely ice-free at any point during that 800,000 year window. The ice was there, growing and shrinking, yes, but always present. Could the story be different if we could drill deeper? Could there have been a brief warm period between 800,000 years ago and 1,000,000 years ago, or farther back, when more of Antarctica was accessible? Possibly. But humans didn't exist 1,000,000 years ago, at least not in the form that could build boats and draw maps. So we're left with a puzzle. Maps that seem to show too much. A continent that seems to have been frozen too long. And a nagging question: is there something we're missing? Some piece of the puzzle we haven't found yet? Or is it simpler than that? Are the maps just maps, subject to the errors and imaginations of their creators? Is Antarctica just frozen, with no human story hidden beneath its ice? Is the mystery more about our desire for mystery than about actual hidden history? Perhaps. But even if the maps are coincidences and Antarctica has no human secrets, the story of how Antarctica froze is still profound. It tells us that climate can change dramatically, that continents can drift from warmth to cold, that ice, once established, can persist for millions of years, covering and hiding everything beneath it. And it reminds us that Earth is a dynamic place, that the world we see now is not the world that always was, that landscapes change, climates shift, and that nothing is truly permanent, not even ice that seems eternal. Antarctica froze, but before it froze, it was green. And millions of years from now, if plate tectonics continues, it might drift north again, thaw, and bloom once more with life. For now, though, it remains frozen, silent, holding its secrets, if it has any, beneath miles of ice. And we are left to wonder and speculate, piecing together clues from old maps and ice cores and satellite images, trying to understand when and how Antarctica became the white continent at the bottom of the world. The warming begins while Antarctica was freezing and would remain frozen for millions of years. The rest of the world was experiencing dramatic climate cycles, and it is in these cycles, particularly in the most recent ice age and its ending, that we find the context for the great catastrophes that may have destroyed lost civilizations and drowned entire continents. 20,000 years ago, as we've seen, Earth was in the grip of the last glacial maximum. Ice sheets covered vast portions of the northern continents. Sea levels were more than 100 meters lower than today. The climate was colder and drier globally. This was the peak of the Ice Age, the point of maximum cold and maximum ice. But even at this peak, the seeds of change were already present, because Earth's climate doesn't change randomly. It follows patterns driven by orbital mechanics. The Milankovitch cycles we mentioned earlier, those slow changes in Earth's orbit and axial tilt, were gradually shifting in ways that would bring more solar energy to the northern hemisphere during summer months. And that additional energy, though small in absolute terms, would be enough to tip the balance. Around 19 to 20,000 years ago, the first signs of warming began to appear. Very subtle at first. Summer temperatures in the northern hemisphere rising slightly, glaciers melting a bit more in summer than they grew in winter. The ice sheets, which had been advancing for tens of thousands of years, paused. And then, slowly, they began to retreat. This retreat wasn't uniform or steady. Climate never changes in a straight line. There were advances and retreats, warmer pulses and colder reversals. But the overall trend, once it began, was toward warming. The Ice Age was ending. Not instantly, not catastrophically at first, but gradually over thousands of years. By about 15,000 years ago, the warming had accelerated. This period is called the BA lulling, Ulled interstadial in scientific terminology, but we can simply call it the first great thaw. Temperatures rose significantly, especially in the northern hemisphere. In some regions, summer temperatures approached or even exceeded modern levels. The great ice sheets covering North America and northern Europe began to melt in earnest. Imagine what this meant for the landscape. Glaciers that had been stable or even advancing for thousands of years suddenly started flowing faster, thinning and retreating. Ice that had covered the land since time immemorial began to disappear. Underneath the ice, the land that was revealed was scraped bare, scarred by the passage of millions of tons of ice. At first, it was barren, just rock and gravel and meltwater. But gradually, as the climate warmed, tundra vegetation appeared. Then shrubs. Then, in the more southerly regions, forests began to spread northward, reclaiming territory that had been frozen for 100,000 years. Animals followed the changing vegetation. Species that had been restricted to ice, free refuges during the glacial maximum began to expand their ranges. Reindeer and caribou moved north. Bison spread across newly available grasslands. Forests brought deer, elk, and smaller mammals. The whole ecosystem was shifting, responding to the changing climate, flowing north like a slow motion wave following the retreating ice. And humans followed too, because humans are nothing if not adaptable. As new territories opened up, human populations moved into them, following the game they hunted, seeking new resources, exploring landscapes that no human had walked on for tens of thousands of years, if ever. This was a time of expansion, of opportunity. More land meant more resources, meant more food, meant larger populations. But with the warming came other changes too, changes that would have profound and sometimes catastrophic consequences. As the ice sheets melted, all that water had to go somewhere, and it went into the oceans, slowly at first, then faster. Sea levels began to rise. Remember, during the glacial maximum, sea levels were about 120 meters lower than today. All that missing water was locked up as ice on land, but now the ice was melting. And as it melted, it flowed as meltwater down rivers and into the seas. Year by year, the sea level crept upward, centimeter by centimeter, meter by meter, gradually but relentlessly reclaiming the land that had been exposed during the Ice Age. For people living on the coasts, and remember that most people live near coasts where resources are richest, this rising sea was a slow motion disaster. Not in a single lifetime, perhaps. The rise was gradual enough that any one individual might not notice much change. But over generations, the pattern would be clear. The shore where your grandparents fished is now underwater. The hunting grounds your parents knew are now marshland, then lagoon, then open sea. Bit by bit, the land is disappearing. And it wasn't just a matter of the shoreline moving. Rivers changed too. As sea levels rose, river mouths drowned. Rivers that used to flow across exposed continental shelves to reach the sea now found the sea coming to meet them, turning their lower reaches into estuaries. Low-lying river valleys flooded, creating bays and inlets. The whole geography of the coastal zones was being rewritten by the rising water. For human communities, this meant displacement. Villages built on what was once safe ground found the sea encroaching. Eventually, they would have to move. Upland, inland, away from the resources they'd relied on. And where they moved, they might encounter other groups who were already there. Competition for territories. Conflicts, perhaps, or cooperation, or amalgamation of groups. The social fabric of human communities would have been strained by these migrations forced by rising seas. This period, from about 15,000 to 13,000 years ago, was a time of dramatic environmental change. The biloileling, alid warming transformed vast areas of the northern hemisphere. It was also a time of cultural change for humans. In the archaeological record, we see new tool technologies emerging, more sophisticated hunting implements, evidence of long-distance trade increasing, possible signs of larger, more complex social groups forming. One of the most significant developments during this period was the beginning of what would eventually become agriculture. Now, full-scale agriculture doesn't develop until later, around 10,000 years ago. But the seeds of it, both literal and metaphorical, were being planted during this warming period. In the Middle East, in the Fertile Crescent, humans began to pay more attention to certain plants: wild wheat and barley, lentils and chickpeas. They weren't farming them yet, not planting and harvesting in the deliberate way we think of as agriculture, but they were managing them, encouraging their growth, beginning the long process of domestication that would eventually transform human society. Why did this happen during the warming period? Partly because the warming climate made these plants more abundant, partly because human populations were growing and needed more reliable food sources, and partly, perhaps, because the social changes forced by rising seas and migrating populations created opportunities for new ways of doing things. Crisis often drives innovation, and the end of the Ice Age was certainly a time of crisis, even if it played out over thousands of years. But the warming wasn't uniform across the globe. Antarctica, remember, remained frozen. The changes there were minimal compared to the northern hemisphere. The Southern Ocean did warm somewhat, and the ice sheets around Antarctica's edges may have retreated slightly, but nothing like the dramatic melting happening in the north. Antarctica's isolation, maintained by the circumpolar current, kept it in its own cold world even as much of the rest of the planet warmed. The northern ice sheets, though, were melting dramatically. The Laurentide ice sheet, which covered much of Canada and the northern United States, was losing mass rapidly. Meltwater poured off its southern edges, carving huge river valleys. Some of this meltwater fed into the Mississippi River system and flowed south to the Gulf of Mexico. Some flowed east and eventually reached the Atlantic Ocean through the St. Lawrence Valley, though this route was often blocked by ice dams. These meltwater flows were not small streams. They were enormous torrents, carrying millions of cubic meters of water every day. The largest meltwater floods in this period would have dwarfed anything we see in modern rivers. They carved valleys, deposited huge amounts of sediment, and delivered vast quantities of fresh water into the oceans. And this fresh water had effects beyond just raising sea levels. Fresh water is less dense than salt water. When huge amounts of fresh water from melting glaciers entered the North Atlantic, it formed a layer of lighter water floating on top of the denser, saltier ocean water. This disrupted the ocean currents that normally circulate warm water from the tropics to the North Atlantic. The Gulf Stream and related currents weakened, and when these currents weaken, the northern regions that depend on them for warmth cool down again. This is a feedback mechanism. Warming melts ice. Meltwater disrupts ocean currents. Disrupted currents cause cooling. Cooling slows the melting or even causes ice to re-advance. It's one of the ways Earth's climate system regulates itself, preventing runaway warming or cooling. But it also makes climate change during ice age transitions very unstable. Instead of a smooth transition from cold to warm, you get fits and starts, warm pulses followed by cold snaps, advances and retreats, a chaotic dance between warming and cooling forces. For people living through this, it must have been deeply unsettling. Imagine a lifetime where summers get warmer, game animals more abundant, life easier. And then, perhaps over just a few years, the climate shifts back. Winters get harsh again. Summers cool. The game animals move away. Food becomes scarce. And this isn't a brief cold snap, but a sustained cooling that lasts decades or centuries. That's the kind of climate instability that characterized the end of the Ice Age. But even with these fluctuations, the overall trend during the Beerwehleling Allard period was warming. The ice continued to retreat. Sea levels continued to rise. Life continued to expand into newly available territories. And humans continued to adapt, as we always have, finding new ways to survive, new strategies for hunting, new foods to eat, new territories to explore. And then, just when it seemed the warming would continue indefinitely, when the Ice Age seemed to be ending smoothly, something happened. Something that threw the entire process into reverse. Suddenly, catastrophically, the climate plunged back into full Ice Age conditions. Temperatures dropped dramatically. Glaciers that had been retreating began to advance again. In some regions, the cooling was so severe and so rapid that it would have been apparent within a single human lifetime. This event, which scientists call the Younger Dryas, was one of the most dramatic and mysterious climate shifts in recent geological history. It interrupted the warming that had been building for thousands of years. It brought back Ice Age conditions for more than a millennium, and it may have been the catastrophe that destroyed any advanced civilizations that had developed during the warmer Beerwehleling Allard period. What caused the Younger Dryas? Why did the warming stop so abruptly? And what happened to the humans and animals living through this sudden return to Ice Age cold? These are questions we need to explore, because the Younger Dryas is the key to understanding what happened when the Ice Ages truly ended. It was the last gasp of the Ice Age, the final test that humans and other species had to survive before the modern warm period could begin. The warming had begun, but it would be interrupted by catastrophe before it could complete. And that catastrophe would change everything. The Younger Dryas 12,900 years ago, something happened. Something dramatic enough to reverse thousands of years of warming in what might have been just decades or even years. The climate, which had been steadily warming for millennia, plunged back into Ice Age conditions almost overnight in geological terms. This event is called the Younger Dryas, named after a hardy Arctic flower, Dryas octopetola, whose pollen suddenly reappears in sediment layers from this time, indicating a return to tundra conditions in regions that had become temperate. The Younger Dryas lasted approximately first 200 years, from roughly 12,900 years ago until 11,700 years ago. During this period, temperatures dropped dramatically. In some regions, particularly around the North Atlantic, temperatures fell by 10 to 15 degrees Celsius within decades. That's an extraordinary rate of change. To put it in perspective, the warming we're experiencing now due to human-caused climate change is happening at a rate of about 1 degree Celsius per century, which scientists consider alarmingly rapid. The Younger Dryas cooling was 10 to 15 times faster. For people and animals living through it, this would have been catastrophic. Imagine you're living in what is now northern Europe during the warmer Beerwehleling Allard period. The climate has been improving for generations. Your grandparents told stories of harder times, but you've known only relative abundance. Forests have spread. Game is plentiful. Your community has grown. Life is good. And then, within your lifetime, everything changes. Summers become shorter and cooler. Winters grow longer and harsher. The forests begin to die back, replaced by tundra vegetation. The animals you depend on migrate south, following the changing climate. Food becomes scarce. Your community, which had grown during the good times, is now too large for the resources available. People starve. Children don't survive their first winters. Within a generation, your population has crashed. This wasn't just a local phenomenon. The Younger Dryas affected the entire northern hemisphere. It was most severe around the North Atlantic, where temperatures dropped the most dramatically. But evidence of cooling has been found in ice cores from Greenland, sediment cores from lakes across Europe and North America, and even in tropical regions where certain temperature-sensitive organisms show signs of cooling during this period. The glaciers that had been retreating for thousands of years stopped their retreat. In some regions, they began to advance again, not to the full extent of the last glacial maximum, but enough to reverse much of the progress that had been made. Glaciers in Scotland, Scandinavia, and the Alps all show evidence of advancing during the Younger Dryas. In North America, parts of the Laurentide ice sheets stabilized or even grew slightly. Sea level rise, which had been steadily lifting the oceans as glaciers melted, slowed dramatically. The water that had been flowing into the oceans from melting ice suddenly decreased as the melting stopped or slowed. This must have been confusing for coastal populations. For generations, the sea had been rising, forcing communities to move inland. Suddenly, the rise stopped. But the damage was already done. The lands that had been drowned stayed drowned, and the reprieve was temporary. What caused this sudden return to Ice Age conditions? This is one of the great questions in paleoclimatology, and despite decades of research, there's still no complete consensus. But several theories have been proposed, and the truth might involve some combination of them. The traditional explanation involves changes in ocean circulation, specifically the Atlantic meridional overturning circulation, of which the Gulf Stream is a part. This circulation system brings warm water from the tropics northward to the North Atlantic, releasing heat that warms Europe and eastern North America. The warm surface water cools and becomes denser, eventually sinking to the deep ocean and flowing back south. It's a conveyor belt of heat, constantly moving warm water north and cold water south. But this system is sensitive to the salinity of the surface water. When the enormous meltwater floods from the retreating ice sheets poured into the North Atlantic during the boiling alid warming, they added vast amounts of fresh water to the ocean surface. Fresh water is less dense than salt water, so it doesn't sink as readily. If too much fresh water accumulates, it can prevent the normal sinking of cooled surface water, disrupting the entire circulation system. The theory is that around 900 years ago, a particularly large pulse of meltwater entered the North Atlantic, perhaps from the sudden drainage of a large glacial lake, and this fresh water disrupted the ocean circulation. The Gulf Stream weakened or even temporarily shut down. Without the heat it normally delivers, the regions around the North Atlantic cooled rapidly, triggering the Younger Dryas. This explanation fits some of the evidence. There's geological evidence for large meltwater floods during this period, and climate models show that disrupting the Atlantic circulation can cause rapid cooling in the northern hemisphere. But there are problems with this theory too. Some evidence suggests the meltwater pulse happened slightly after the Younger Dryas cooling began, not before it, and the geographical pattern of cooling doesn't perfectly match what you'd expect from ocean circulation changes alone. An alternative theory, which has gained considerable attention in recent years, though it remains controversial, is that the Younger Dryas was triggered by an extraterrestrial impact. Specifically, that a comet or asteroid struck Earth or broke up in the atmosphere, creating multiple airbursts around 900 years ago. The impacts or airbursts would have caused widespread fires, thrown dust and aerosols into the atmosphere, and possibly destabilized ice sheets, all contributing to rapid climate change. Evidence for this impact hypothesis includes a layer of sediment dating to the start of the Younger Dryas that contains unusual materials. This layer, called the Younger Dryas boundary layer, has been found at sites across North America and in some other regions. It contains elevated levels of platinum and other elements rare on Earth's surface but common in meteorites. It contains nanodiamonds, microscopic diamonds that can form under the extreme pressures of an impact. It contains tiny magnetic spherules and other particles consistent with high temperature events like impacts or airbursts. And in some locations, it contains a layer of black, carbon, rich material suggesting widespread burning. Proponents of the impact hypothesis point to this evidence and argue that a comet, possibly a fragment of a larger comet that broke up as it entered the inner solar system, struck North America around 900 years ago. The impact or airburst would have caused immediate devastation across a wide area. Forests would have burned. Animals would have been killed directly by the blast or indirectly by the fires and subsequent climate effects, and humans living in the impact zone would have faced catastrophe. But the effects wouldn't have been purely local. The dust and smoke thrown into the atmosphere would have blocked sunlight, cooling the planet. The impact might have destabilized the Laurentide ice sheet, causing massive meltwater floods that disrupted ocean circulation, triggering longer-term cooling. The combination of these effects could explain the rapid onset and long duration of the Younger Dryas. Critics of the impact hypothesis point out that not all sites from this time period show the proposed Younger Dryas boundary layer. Some of the evidence, like the nanodiamonds, can form through natural processes without requiring an impact, and no impact crater of the right age and size has been definitively identified, though proponents suggest the impact might have been on the Laurentide ice sheet, which would have hidden or destroyed evidence of a crater. The debate continues. New evidence is found and interpreted differently by different researchers. Some are convinced an impact occurred. Others think the evidence is ambiguous or explicable by other means, and many think the truth might be complex, involving both terrestrial processes like meltwater floods and possible extraterrestrial contributions. What we can say for certain is that something caused the Younger Dryas. The cooling was real, dramatic, and rapid. Whether it was purely terrestrial processes, an impact, or some combination, the effect on Earth's climate was profound. And for the humans and animals living through it, the cause didn't matter as much as the consequences. Those consequences were severe. The rapid cooling and return to ice age conditions would have been deadly for many populations. Archaeological evidence suggests human populations declined significantly during the Younger Dryas. Sites that show evidence of occupation before the event show either abandonment or much reduced activity during the once 200 years of cooling. The megafauna, the large ice age animals that had survived the warming of the Beer-Lulling Alad period, began to decline more rapidly during the Younger Dryas. Mammoths, mastodons, giant ground sloths, and many other large mammals went extinct or declined dramatically during or shortly after this period. The causes of these extinctions are debated, with climate change, human hunting, and possibly the impact all playing roles. But the timing is striking. The megafauna had survived for thousands of years through previous climate changes. But the rapid warming, followed by the Younger Dryas cooling, followed by rapid warming again, proved too much. Within a few thousand years of the Younger Dryas, most of the large Ice Age mammals were gone. For humans, the Younger Dryas was a time of hardship but also adaptation. We didn't go extinct, we survived, but we had to change how we lived. In some regions, people abandoned hunting the megafauna and focused on smaller game and plant foods. In other regions, including the Fertile Crescent, the hardships of the Younger Dryas may have accelerated the development of agriculture. When wild foods become scarce and unreliable, cultivating plants becomes more attractive despite the additional labor required. And then, after Fun's 200 years of cold, the Younger Dryas ended. As abruptly as it began, it stopped. Around 700 years ago, temperatures shot back up. The warming resumed, even faster than before. Within decades, perhaps just years in some regions, temperatures rose to pre-Younger Dryas levels and then surpassed them. The glaciers began their final retreat. Sea levels began rising again, faster now. The modern interglacial period, the Holocene, had begun. This final warming, the end of the Younger Dryas and the beginning of the Holocene, was the true end of the Ice Age. It was rapid, dramatic, and irreversible. Within a few thousand years, the great ice sheets of North America and Europe had melted completely. Sea levels rose the final tens of meters to near modern levels. The climate stabilized into the warm, relatively stable pattern we've known for the last 700 years. But the transition was not easy. The rapid warming and final melting of the ice sheets caused catastrophic floods, drowned vast areas of coastal lowlands, and forced massive human migrations. This was the Great Flood that appears in myths around the world. This was when Doggerland drowned, when Sundaland disappeared beneath the waves, when the Persian Gulf filled with water. This was when coastal civilizations, if they existed, would have been destroyed. The Younger Dryas was the last gasp of the Ice Age, but it was also the setup for the final catastrophe. The interruption of the warming allowed ice sheets to stabilize or even grow slightly. And when the warming resumed, all that ice had to melt, and it melted fast. The result was a pulse of sea level rise more rapid than anything that had come before, a deluge that would have been terrifying for anyone living on low-lying coasts. And those coasts, remember, were where most people lived, where the richest resources were, where any advanced civilizations would have developed, all of it underwater now. All evidence of what existed before, drowned beneath the rising seas, leaving only memories preserved in myths and perhaps fragments of knowledge, preserved in ancient maps passed down through generations. The Younger Dryas was the hinge point, the moment when the Ice Age's grip was finally broken, but not without a final, brutal test of survival. Those who made it through saw a world transform before their eyes, from ice to warmth, from lowlands to rising seas, from one age to another, and they carried forward the knowledge and memories of what had been lost. Or so the theory goes. Whether there really were advanced civilizations destroyed by these events remains debated. But there's no debate that the events themselves were real, dramatic, and world-changing. The Younger Dryas happened, and when it ended, everything changed. The death of giants, the world of 15,000 years ago, was populated by giants. Not mythological creatures, but real animals of extraordinary size. Creatures that would dwarf most animals alive today. Creatures that had dominated the landscapes of the Pleistocene epoch for hundreds of thousands of years. And then, within just a few thousand years, most of them disappeared, vanished from the earth, went extinct. This is one of the great mysteries and tragedies of the end of the Ice Age. The extinction of the megafauna, the death of giants. Picture a woolly mammoth, not from a museum display or artist's reconstruction, but alive, breathing, moving through its world. Standing 4 meters tall at the shoulder, weighing 6 tons or more, covered in thick, shaggy brown hair that hangs in curtains from its body, providing insulation against the bitter cold. Curved tusks extending 4 meters or more, tools for pushing snow aside to reach vegetation, for fighting, for display. Small ears and a short tail, adaptations to minimize heat loss in the frigid climate. Woolly mammoths ranged across the northern hemisphere, from Western Europe through Siberia and across Beringia into North America. They were perfectly adapted to the cold grasslands and tundra of the Ice Age world. They survived by eating vast quantities of grass, sedges, and other vegetation. A single mammoth might consume 200 kilograms of plant material every day. They lived in small herds, probably matriarchal like modern elephants, with experienced females leading groups through seasonal migrations, teaching younger members where to find food and water, how to survive the harshest winters. And they had survived for hundreds of thousands of years through multiple advances and retreats of glaciers, through climate swings far more dramatic than anything modern elephants have experienced. Mammoths persisted. They were one of the great success stories of Ice Age evolution. But by 10,000 years ago, they were gone from most of their range. Small populations hung on in isolated refuges. A population on Wrangel Island off the coast of Siberia survived until about 4,000 years ago. But the vast herds that once roamed the mammoth steppe were no more. The grasslands that had sustained them were empty of their massive forms. Mammoths were not alone in their extinction. The list of megafauna that disappeared at the end of the Ice Age is staggering. In North America, the Columbian mammoth, even larger than the woolly mammoth, went extinct, as did the American mastodon, another elephant relative that lived in forested areas and browsed on trees and shrubs rather than grazing grass. The giant ground sloths, some species of which were as large as modern elephants, disappeared. These bizarre creatures had evolved in South America and migrated north when the Isthmus of Panama formed, connecting the continents. They were slow-moving, plant eaters with massive claws used for pulling down branches and digging for roots. The saber-toothed cats vanished. Both Smilodon, with its enormous curved canines, and Homotherium, a more cursorial saber, tooth-adapted for running down prey. These were apex predators that had dominated for millions of years. The dire wolf, larger and more powerful than modern grey wolves, went extinct. The short-faced bear, one of the largest terrestrial carnivores that ever lived, disappeared, standing 4 meters tall on its hind legs, capable of running down prey at high speed, The short-faced bear was a nightmare predator. Gone. Giant beavers, the size of modern black bears. Ancient bison, with horn spans approaching 3 meters. Camels and horses, both of which evolved in North America before spreading to other continents and then going extinct in their homeland. Glyptodons, armored relatives of modern armadillos the size of small cars. Toxodon, massive hippo-like creatures. Giant capybaras, all extinct. In Eurasia, the woolly rhinoceros disappeared. Cave bears, massive brown bears that hibernated in caves and whose bones are found in huge concentrations across Europe, went extinct. The European lion and cave lion vanished. The giant Irish elk, with antlers spanning 3.5 meters, the largest antlers of any deer species ever, disappeared from the landscape. In Australia, which had its own unique megafauna, the extinctions were perhaps even more dramatic. Diprotodon, the largest marsupial that ever lived, a 3-ton wombat-like creature, went extinct around 25,000 years ago. Giant kangaroos, standing over 2 meters tall. Megalania, a giant monitor lizard up to 7 meters long. The marsupial lion, a predator with bolt-cutter jaws. An entire ecosystem of giant marsupials vanished. The pattern holds globally. Wherever you look, the largest animals vanished at the end of the Ice Age. In Madagascar, giant lemurs and elephant birds disappeared after humans arrived. In New Zealand, the moa, giant flightless birds, went extinct soon after Polynesian settlement. Islands around the world saw their largest species disappear when humans reached them. The scale of this extinction event is difficult to overstate. In North America, about 70% of large mammal species went extinct. In South America, a similar percentage. In Australia, the megafauna extinctions were nearly complete. Eurasia lost a somewhat smaller proportion, but still suffered massive losses. This was a global catastrophe for large animals. What caused these extinctions? This question has been debated for decades, and the debate continues today. But several factors seem to have played roles, probably in combination rather than any single cause explaining everything. Climate change is certainly part of the story. The end of the Ice Age brought dramatic environmental changes. Grasslands gave way to forests in many regions. Tundra retreated northward. Deserts expanded in some areas. The plant communities that megafauna had evolved to eat were changing or disappearing. For animals adapted to specific environments, these changes would have been challenging. Woolly mammoths, for example, thrived on the cold, dry grasslands of the mammoth steppe. But as the climate warmed and those grasslands were replaced by boreal forests, their habitat shrank. Forests don't support the same density of large grazers that grasslands do. The mammoths would have found less food in a more closed environment. But climate change alone doesn't explain the extinctions. Large animals had survived previous climate changes. The ice ages were cyclical, with multiple glacial and interglacial periods over the last 2 million years. Each transition brought habitat changes. Yet the megafauna survived these previous shifts. Why did they fail to survive this one? This is where the second major factor comes in: humans. The timing of megafauna extinctions correlates remarkably well with human expansion across the globe. In Africa and parts of Eurasia, where humans and megafauna had co-evolved for hundreds of thousands of years, extinction rates were lower. But in regions that humans reached relatively recently, extinction rates were catastrophic. Australia's megafauna began disappearing around 45,000 to 50,000 years ago, right when humans arrived on the continent. North America's extinctions cluster around 13,000 to 10,000 years ago, the period when human populations were expanding rapidly across the continent. Islands around the world show the same pattern. Humans arrive, large animals go extinct shortly after. This correlation doesn't prove causation, but it strongly suggests humans played a significant role. The question is how exactly humans contributed to the extinctions. The obvious answer is hunting. Humans are efficient hunters. We use tools, we cooperate in groups, we plan and strategize. A coordinated group of human hunters with spears could kill even the largest animals. And unlike other predators, we don't just kill what we need for immediate consumption. We can preserve meat, plan for the future, kill surplus animals for feasts, or to store against lean times. The overkill hypothesis suggests that human hunting was the primary cause of megafauna extinction, particularly in regions where animals had no previous experience with human hunters. They would have been naive, not recognizing humans as a threat. This would have made them easy prey. And once human populations started growing, hunting pressure might have exceeded the reproductive rate of slow, breeding large animals, driving them to extinction. There's evidence supporting this. Many megafauna species, particularly the largest ones, are slow breeding. Elephants, for example, have long gestation periods and long intervals between births. They invest heavily in each offspring. This strategy works fine when mortality is low. But if humans start killing more adults than are being born, populations decline. And once a population gets too small, random chance can drive it to extinction even without continued hunting pressure. Archaeological sites show clear evidence of humans hunting megafauna. Mammoth kill sites with stone tools, butchered bones of extinct species. Rock art depicting now extinct animals showing humans interacting with them. The evidence of hunting is unambiguous, but hunting alone might not be the whole story. Humans affect environments in ways beyond direct killing. We use fire to manage landscapes, burning grasslands to encourage new growth that attracts game animals. These fires can alter ecosystems on large scales. We compete with megafauna for resources, even if we're not hunting them directly. Our presence changes animal behavior, stress levels, migration patterns. And there's disease. Humans bring with us pathogens, parasites, and microorganisms. When we enter new ecosystems, we can introduce diseases that native animals have no immunity to. This has happened repeatedly in historical times. Could something similar have happened to Ice Age megafauna? It's possible, though hard to prove from ancient remains. The reality is probably that all these factors interacted. Climate change was stressing megafauna populations, reducing their habitats, changing their food sources. Then humans arrived, adding hunting pressure, altering landscapes with fire, competing for resources, possibly introducing diseases. The combination was too much. Species that might have survived climate change alone or human hunting alone couldn't survive both together. The Younger Dryas adds another layer of complexity. The rapid climate whiplash, warm, cold, warm, would have been particularly stressful for large animals with slow reproduction. Populations reduced during the Younger Dryas cooling might not have had time to recover before the final warming and its ecological disruptions finished them off. And if the impact hypothesis is correct, If a comet really did strike North America at the beginning of the Younger Dryas, that would have added immediate catastrophic mortality on top of everything else. The impact, fires, and subsequent climate chaos would have killed vast numbers of animals directly and destroyed habitats across a huge area. Populations already stressed by human hunting and climate change might not have been able to recover from such a sudden additional blow. The megafauna extinctions transformed ecosystems in ways we're still uncovering. When you remove the largest herbivores, you change how plants grow, how nutrients cycle through the environment, how fires spread, even how much carbon is stored in soils versus vegetation. Some scientists argue that the extinction of megafauna helped lead to forest expansion in some regions because there were no longer huge herds of elephants and other large herbivores knocking down trees and maintaining open grasslands. There's even a theory that megafauna extinction contributed to climate change. Large animals produce methane, a greenhouse gas. Millions of mammoths, mastodons, and other large herbivores would have produced substantial amounts of methane. Their extinction would have reduced atmospheric methane, possibly contributing to cooling. It's a speculative idea, but it shows how interconnected these events may have been. For the few megafauna species that survived, the world became a lonelier, emptier place. African elephants, which still had to contend with human hunting but had evolved alongside humans and had developed appropriate wariness, survived. Bison in North America, which were smaller and faster, breeding than the extinct giant bison, survived, though they would later face their own near extinction at human hands. Musk oxen, adapted to the harshest Arctic conditions and living in regions with low human population density, survived. But the great Pleistocene megafauna assemblage was broken. The mammoth steppe, that vast grassland ecosystem that stretched from Western Europe to the Yukon, supporting diverse communities of large mammals, was gone. Replaced by forests in some areas, tundra in others, but nowhere supporting the density and diversity of megafauna that had characterized the Ice Age world. There's something deeply sad about the extinction of these animals. They weren't failed experiments of evolution, evolutionary dead ends that deserved to go extinct. They were successful species that had thrived for hundreds of thousands of years. Woolly mammoths survived for at least 700,000 years. Compare that to Homo sapiens, who have existed for perhaps 300,000 years. By any measure of success, mammoths were more successful than we have been so far. But they're gone. We have their bones, their frozen remains in permafrost, their traces in rock art and archaeological sites. We can study them, reconstruct what they looked like, understand their ecology. But we can never see a living mammoth, never watch herds of ground sloths moving through South American forests, never witness saber-toothed cats hunting on the grasslands. The world of the megafauna is lost. And whether humans were primarily responsible, or climate change, or some combination, we are the inheritors of a world made emptier by their absence. The giants are dead, and the echoes of their loss still reverberate through the ecosystems they once shaped, in ways we're only beginning to understand. The flood begins. Imagine waking one morning to find the ocean closer to your village than it was yesterday. Not by much. Perhaps just a few meters. Maybe you notice the high tide line is higher than you remember. Maybe the beach where children played is narrower. Maybe the freshwater spring near the shore tastes slightly brackish now, contaminated by seawater seeping through the ground. You might not think much of it. Tides vary. Storms push water inland. These things happen. You go about your day, fishing, gathering, hunting, tending to your family and your community. But the next year, the water is closer still. And the year after that, and after that, generation after generation, the sea advances. Land that your grandparents knew as hunting grounds is swamp now, then shallow water, then part of the ocean. The coastline your parents showed you as children is gone, claimed by rising waters. And you watch over your lifetime as the sea continues its relentless advance. This was the reality for countless human communities at the end of the Ice Age. The flood didn't happen overnight. It wasn't a biblical deluge that covered the world in 40 days, but over centuries and millennia, it was just as devastating. More so, perhaps because it was inescapable. You could run from a single storm, flee from a tsunami. But you cannot outrun the ocean when it decides to rise. The Great Flooding began in earnest around 15,000 years ago, accelerated after the Younger Dryas ended 700 years ago, and continued until about 7,000 years ago. Over those 8,000 years, sea levels rose approximately 120 meters. That's a 40-story building worth of water added to the world's oceans. Coastlines that had been stable for thousands of years during the last glacial maximum were drowned. Continental shelves that had been dry land were submerged. Islands disappeared. Entire ecosystems were erased, replaced by salt water. To understand the scale, picture what 120 meters of sea level rise means. Every coastal plain, every river delta, every lowland within that elevation of the Ice Age coastline was flooded. The Persian Gulf, which had been dry land with rivers flowing through it, filled with water, transforming from a river valley into a sea. The English Channel, which didn't exist when sea levels were low, formed, separating Britain from continental Europe. Indonesia, which had been part of a vast landmass called Sundaland, fragmented into thousands of islands. The eastern coast of North America was drowned for hundreds of kilometers inland in some places. This wasn't a gradual, smooth rise. The melting of ice sheets and the consequent sea level rise happened in pulses, periods of rapid increase followed by slower periods. These pulses correspond to catastrophic collapses of ice sheets, events where enormous volumes of ice melted in geologically short periods, dumping vast quantities of fresh water into the oceans. The first major pulse is called Meltwater Pulse 1A. It occurred around 14,000 years ago during the B.A. Lelling, Alid warming period. In the span of perhaps 500 years, sea levels rose between 16 and 25 meters. That's roughly 3 to 5 centimeters per year on average, though the rise likely wasn't uniform. Some periods within that 500 years may have seen even more rapid increases. 3 to 5 centimeters per year doesn't sound like much. You could step over that. But sustained over decades, it means the ocean advances tens of meters inland. Over a human lifetime of 50 years, that's 5 meters of sea level rise. Enough to drown entire villages. Enough to force communities to relocate inland repeatedly. Enough to change the shape of the world. And unlike modern sea level rise, which affects relatively steep coastlines in many regions, Ice Age sea level rise was drowning the continental shelves. These were vast, flat, or gently sloping areas. A meter of sea level rise on a shelf sloping at 1 in 1,000 means the ocean advances 1 kilometer inland, 2 meters of rise, 2 kilometers. Over a lifetime of 5 to 2. 5 meters of rise, the ocean could advance 500 to 500 meters. From the perspective of someone living on these coasts, the ocean was advancing kilometers every few decades. Where did all this water come from? From the ice. The great ice sheets that had covered much of North America and Europe began to collapse. The Laurentide ice sheet, which had covered Canada and the northern United States, contained enough water to raise sea levels by over 50 meters if it melted completely. The Fennoscandian ice sheet covering northern Europe contributed more. Smaller ice sheets in the Andes, on Patagonia, in the Himalayas, all contributed. Mountain glaciers around the world melted. Even the Greenland ice sheet, which still exists today, was larger during the Ice Age and contributed to sea level rise as it shrank. The mechanism is straightforward. Ice sheets form from snow accumulation. For tens of thousands of years during the Ice Age, snow fell on the northern continents, accumulating year after year, compressing into ice, building ice sheets kilometers thick. All that water was locked up as ice on land. It wasn't in the oceans, so sea levels were lower. When the climate warmed, the ice began to melt. Meltwater ran off the ice sheets, flowed down rivers, and poured into the oceans. The water returned to where it had come from originally, evaporated from the oceans, fallen as snow on land, and now returning to the sea. But from the perspective of coastal dwellers, this wasn't water returning. This was the ocean invading their world. The second major pulse of sea level rise, Meltwater Pulse 1b, occurred around 11,500 years ago, right at the end of the Younger Dryas and the beginning of the Holocene. The Younger Dryas had allowed some ice sheets to stabilize or even grow slightly. When the warming resumed, it was rapid and dramatic. Ice sheets that had been poised on the edge of collapse suddenly did collapse. Estimates for Meltwater Pulse 1b vary, with some studies suggesting a rise of 10 to 15 meters in just a few centuries. Others argue the evidence isn't as clear-cut. But what's certain is that the early Holocene, the period from 11,700 to about 8,000 years ago, saw very rapid sea level rise, the final pulse of deglaciation, the final drowning of the Ice Age coastlines. For humans living through this, the experience would have been terrifying and disorienting. Imagine being part of a coastal community. Your people have lived in this place for generations, perhaps centuries. You know every inlet, every river mouth, every good fishing spot, every freshwater spring. The location of your village relative to the sea is part of your cultural identity, embedded in your stories and your sense of place. And then the sea starts to rise. Slowly at first, so slowly you might think you're imagining it. But year after year, decade after decade, the water advances. The landmarks you used for navigation disappear under the waves. The fishing grounds your ancestors used become too deep. The reefs submerged in darkness. The beaches where you collected shellfish are underwater now, replaced by new beaches further inland. Your community makes a decision. You must move. The old village site is too close to the water now. High tides flood the lower areas. Storm surges reach the central structures. Saltwater contaminates the wells. You pack up what you can carry and move inland, building a new village on higher ground. For a generation, maybe two, the new location works. But the sea continues to rise, and eventually you must move again and again. Each time you leave behind structures, refuse pits, graves, the physical traces of your community's life, all drowned beneath the advancing waves, all buried under sediments as the ocean claims the land. How many times could a community do this before it fractured? Before disputes arose over where to move, over whether to stay near the coast or retreat further inland, before some families decided to migrate to entirely new regions while others insisted on staying near their ancestral lands despite the advancing water. And what about communities that didn't move fast enough? A village built on a low barrier island or a river delta could be overwhelmed by a storm surge during a period of rapid sea level rise. What was survivable one decade might be catastrophic the next, because the baseline sea level is higher. Storms that once lapped at the edge of the settlement now flood through the center. There would have been conflicts. As coastal communities were pushed inland, they moved into territories occupied by other groups. Competition for resources would have intensified. River valleys and lake shores, already desirable locations, would have become even more crowded as refugees from the coasts sought new homes. Some groups would have welcomed the newcomers. Others would have fought to protect their territories. The social disruptions caused by sea level rise would have rippled far inland, affecting communities that never saw the ocean. And there would have been innovation. Humans are adaptable. We don't just give up when faced with environmental change. Some communities might have developed new technologies, new ways of living with the changing coastlines. Boats become more important when the landscape is increasingly waterlogged and fragmented. Fishing techniques might shift as new marine environments formed. Knowledge of tides and sea level changes becomes crucial for survival. But adaptation has limits. You can build your houses on stilts. You can develop flood-resistant storage for food. You can learn to navigate a watery landscape. But when the land you live on disappears completely beneath the waves, adaptation means leaving, means abandoning everything you can't carry, means becoming refugees in a world that's already crowded with other humans trying to survive the same environmental catastrophe. The psychological impact must have been profound. Humans form deep attachments to places. Our identities are tied to the landscapes we know. To watch your homeland slowly disappear beneath the water, knowing you're powerless to stop it, must have been devastating. And unlike a disaster that strikes and then is over, this was ongoing for generations. Children grew up hearing stories about lands that no longer existed, places their grandparents knew, but they would never see. This is where the flood myths come from. Every culture around the world has flood stories. The biblical flood in Genesis, the Mesopotamian epic of Gilgamesh, which predates Genesis and tells a similar story. Hindu texts describing Manu surviving a great flood, Greek myths of Deucalion and the deluge, Norse stories of the world being flooded, Chinese legends of the Great Flood and its taming, Native American traditions of flood and survival, Australian Aboriginal stories of sea level rise, drowning tribal lands. For a long time, scholars assumed these stories were independent inventions, that floods are common disasters, and so it makes sense that many cultures would have flood myths. But the timing is striking. Many of these myths describe floods that drown the world, that force humans to flee to high ground or onto boats, that separate the world before the flood from the world after. Could these myths be cultural memories of the post-glacial flooding, memories of the time when the oceans rose and the coastlines drowned. Passed down through oral traditions for thousands of years, embellished and transformed through retelling, but maintaining a core of truth about a real historical event. It's controversial. Oral traditions can preserve information for impressive lengths of time, but thousands of years. From the Younger Dryas to the early historical period, when these myths were first written down, is 8 to 10,000 years. Can stories survive that long? Some researchers argue yes. Aboriginal Australian oral traditions, for example, appear to contain accurate information about landscapes that were drowned when sea levels rose. Information that has been passed down for 7,000 to 10,000 years and verified by geological evidence. If one culture can do it, others might have as well. The flood myths share certain features. There's a period of safety before the flood. Then the flood comes, sudden or gradual, but unstoppable. The world is transformed. Many people die. A few survive, often by fleeing to high ground or getting onto boats. After the flood, the survivors must rebuild, often with the help of divine beings or with knowledge preserved through the catastrophe. The world after the flood is different from the world before. This narrative structure matches the end of the Ice Age remarkably well. Before the flooding, during the last glacial maximum and early deglaciation, coastal plains were extensive and stable. People lived there for thousands of years. Then the flooding began. It was gradual on human timescales, but catastrophic over centuries. Populations were displaced. Those who could moved inland or to higher ground. Some communities may have developed sophisticated boats or water management systems. After the flooding stabilized, around 7,000 to 8,000 years ago, the world was different. The coastlines had moved. Entire regions were underwater. The survivors carried forward whatever knowledge and traditions they could preserve. If you were a survivor, how would you tell the story to your children? You might simplify it. Say the flood came suddenly, rather than trying to explain centuries of gradual rise. You might attribute it to divine anger or cosmic forces, because what other explanation would make sense without modern scientific knowledge? You might emphasize the importance of the knowledge that allowed your family to survive, whether that's boat, belt, building, navigation, or knowing which routes lead to high ground. And your children would tell their children, who would tell their children. Over generations, the specific details would fade. The names of places that no longer existed would be forgotten or transformed into mythical locations. But the core story would remain. There was a world before, a flood came, and a few survived to build the world after. This is speculation, of course. We can't prove that flood myths derive from memories of post-glacial sea level rise, but the correlation is intriguing, and it's supported by the sheer universality of flood myths. Why would cultures from Australia to Mesopotamia to the Americas all have similar stories unless they were based on similar real events? The post-glacial flooding was global. Every coastline was affected. Every coastal population would have experienced it. And it makes sense that such a traumatic, civilization-altering event would be remembered. The flooding finally began to slow around 7,000 to 8,000 years ago. By that time, most of the ice sheets had melted. Sea levels had risen to within a few meters of modern levels. There was still some adjustment, some continued melting of remaining ice, but the catastrophic phase was over. The coastlines stabilized more or less into the configurations we know today. But the world had been transformed. Vast areas of land, tens of millions of square kilometers, were underwater, and these weren't marginal lands. They were some of the most habitable, resource-rich regions on Earth. River deltas, coastal plains, shallow seas. These are environments where life flourishes, where food is abundant, where human populations thrive, all underwater, and with them, any archaeological evidence of human occupation. Any settlements, any structures, any art or technology buried under meters of sediment, corroded by salt water, scattered by currents. If there were advanced civilizations living on these now drowned lands, their traces would be extraordinarily difficult to find. We're left with questions. What was lost beneath the waves? Who lived on those drowned coastlines? What did they know? What could they do? What did they achieve? We'll never fully know, but we know they existed, those coastal peoples of the Ice Age. And we know they experienced one of the greatest environmental catastrophes in human history. The Great Flood, the drowning of the world, the end of one age and the beginning of another, marked by rising waters and disappearing lands. The ocean took back what it had given, and the age of ice was ending, not with a whimper, but with a deluge. Memories of the deluge, the stories persist. Across continents, across cultures that had no contact with each other for thousands of years, the same narrative appears. A great flood, a world drowned, survivors who preserved knowledge and rebuilt civilization. The details vary, but the core remains consistent. And in recent decades, as archaeologists and geologists have mapped the drowned coastlines of the Ice Age, as they've discovered submerged settlements and landscapes beneath the waves, these ancient stories have begun to look less like myth and more like memory. Consider the Epic of Gilgamesh, one of humanity's oldest written stories, recorded on clay tablets in ancient Mesopotamia around 2100 BCE, but likely originating from oral traditions much older. In the 11th tablet, Gilgamesh meets Utnapishtim, a man who survived the Great Flood sent by the gods to destroy humanity. Utnapishtim tells how he was warned by the god E to build a great boat, seal it with pitch, and bring aboard his family, craftsmen, and seed of all living creatures. The flood came. It lasted 6 days and 6 nights. Water covered everything, drowning the world. When it subsided, Utnapishtim's boat came to rest on a mountain. He sent out birds to find land. Eventually, they returned with signs that the water had receded. Utnapishtim made offerings to the gods, and he was granted immortality as a reward for preserving life through the catastrophe. The parallels to the biblical flood story in Genesis are obvious, because Genesis likely drew from these earlier Mesopotamian traditions. But what's more interesting for our purposes is the possibility that these stories themselves drew from even older memories of when the Persian Gulf was a river valley, when Mesopotamia's coastline was far to the south of where it is today, when sea level rise flooded vast areas and forced populations to flee. The Persian Gulf is a shallow sea, mostly less than 50 meters deep. During the last glacial maximum, when sea levels were 120 meters lower, it didn't exist as a sea. Instead, the Tigris and Euphrates rivers flowed through a valley, joining with rivers from the Arabian Peninsula and flowing south into the much smaller Gulf of Oman. This river valley would have been one of the most fertile, resource-rich environments in the region. Fresh water, abundant vegetation, game animals, fish, an ideal place for human settlement. As sea level rose, the Persian Gulf flooded. Water advanced up the valley, turning a river into an estuary, then a bay, then the sea we know today. This happened over several thousand years, but pulses of rapid sea level rise would have caused dramatic flooding events. Settlements along the river would have been inundated. Communities would have been forced to move again and again as the water advanced. By around 8,000 years ago, the Persian Gulf had reached approximately its modern extent. But the memory of the flooding might have persisted in oral traditions, eventually finding its way into written form as the flood stories of Mesopotamian literature. The details would have been mythologized. A process that took thousands of years becomes a 6-day flood. The gradual inundation becomes a divine punishment. But the core, the memory of water drowning the land and forcing survivors to flee, remains. Similar stories appear in other regions that experienced dramatic sea level rise. The Black Sea, for example, was a freshwater lake during the Ice Age isolated from the Mediterranean. Around 700 to 500 years ago, rising sea levels in the Mediterranean caused water to breach the Bosphorus Strait. Water poured through a massive waterfall that some geologists have estimated might have been 200 times the volume of Niagara Falls. The Black Sea's level rose rapidly, perhaps as much as tens of meters. Coastlines were flooded. Settlements around the lake were drowned. Did the people living around the Black Sea remember this catastrophe? Some researchers have proposed that the Black Sea flood might be the historical event behind various flood myths from the region, including possibly influencing biblical traditions. It's debated, and the timing is challenging to reconcile with the spread of flood stories, but it demonstrates that catastrophic flooding events did occur in human prehistory, events dramatic enough to leave lasting impressions. In India, Hindu texts describe a great flood and the survival of Manu, the first man who was warned by a fish avatar of Vishnu. Manu built a boat, survived the flood, and became the progenitor of humanity after the waters receded. In Greek mythology, Zeus sends a flood to destroy humanity, but Deucalion and his wife Pera survive by building an ark. In Norse mythology, the world is created from the body of the giant Ymir and later nearly destroyed by floods when his descendants are killed by the gods. The Chinese have traditions of the Great Flood, a deluge that threatened to destroy civilization until the hero Yu the Great spent decades taming the waters, dredging rivers, and creating channels to drain the flood. Recent archaeological and geological work has suggested this story might have a basis in a real catastrophic flood around 1920 BCE, caused by a landslide damming a river, and then the dam failing. But the story of Yu also might incorporate older memories of more ancient floods, transformed through millennia of retelling. Indigenous Australian cultures have flood stories that are particularly intriguing because they can sometimes be correlated with specific geological events. The Yolgo people of northern Australia have traditions describing the flooding of what is now the Gulf of Carpentaria. Geological evidence shows this area was dry land during the Ice Age and flooded as sea levels rose, with the Gulf fully formed by around 8,000 years ago. The oral traditions appear to preserve memories of this flooding, passed down for thousands of years, with remarkable accuracy about geographic details. Along the southeast coast of Australia, several Aboriginal groups have traditions about lands that are now islands being connected to the mainland in the past. or about hunting and living on lands now underwater, when researchers map the coastlines as they existed at various sea levels during deglaciation. These traditional stories match the geological evidence. Landscapes described in the stories correspond to landscapes that existed 7,000 to 10,000 years ago before being submerged. This is extraordinary if true. It suggests that oral traditions can preserve accurate geographical information for hundreds of generations. And if Australian Aboriginal cultures could do this, why not other cultures? Why couldn't Mesopotamian flood stories preserve memories of the Persian Gulf flooding? Why couldn't Greek or Hindu or Chinese stories incorporate memories of rising seas and drowned lands? Native American traditions include numerous flood stories. The Ojibwe tell of a great flood that covered the earth, with survivors taking refuge on the back of a turtle. The Haida of the Pacific Northwest have stories of the ocean rising and people fleeing to the mountaintops. The Cowichan people of Vancouver Island describe a time when the sea rose rapidly and people had to tie their canoes to the peaks of mountains to avoid being swept away. The Pacific Northwest coast of North America experienced dramatic landscape changes at the end of the Ice Age. Not only did sea levels rise, drowning the continental shelf, but the land itself rebounded after the weight of the Cordilleran ice sheet was removed, causing complex patterns of relative sea level change. Some areas saw the land rise faster than the sea, creating new coastlines. Other areas were drowned. The landscape was in flux for thousands of years. Communities living through this would have experienced it as their world being fundamentally reshaped. Mountains emerging from the sea as the land rebounded. Valleys flooded as sea levels rose. It would have seemed like the earth and water were fighting for dominance. The Aztecs had a tradition of the world being destroyed and recreated multiple times, with one destruction being by flood. The Maya had similar cyclical concepts, and flood stories appear in various forms throughout Mesoamerican mythology. In South America, the Inca had flood myths, as did cultures in the Amazon basin and the Andes. What's striking is the sheer number and distribution of these stories. It's not just one or two cultures, it's hundreds. From every inhabited continent, cultures that were separated by oceans, that had no contact with each other for thousands of years, telling similar stories about a world destroying flood. The skeptical explanation is that floods are common disasters, and so it's natural that many cultures would develop flood myths independently. River floods happen regularly. Tsunamis occur. Storm surges inundate coastal areas. Any culture living near water would occasionally experience catastrophic flooding, and these experiences would be incorporated into mythology. But there's a difference between a river flooding its banks, destructive though that is, and stories about the entire world being drowned, about waters rising to cover mountains, about the fundamental reshaping of the earth. The latter sounds less like the description of a local flood and more like the description of sea level rise, particularly the aspect of the flood being followed by a new world, different from the world before. That's not how a river flood works. The water rises, destroys things, and then recedes. The landscape returns to normal, minus whatever was destroyed. But sea level rise permanently changes the landscape. After the water rises, it doesn't recede. The world after is different from the world before, exactly as the myths describe. There's also the question of why these myths are so important to so many cultures. Floods, if they were just common disasters, would be one danger among many. Droughts, earthquakes, volcanic eruptions, wildfires, these are all catastrophes that kill people and destroy communities. Yet flood myths are uniquely widespread and central to many cultures' creation narratives. The flood is often described as the event that separates the mythological past from the historical present, the destruction that necessitated rebuilding and shaped the world as we know it. This suggests the floods described aren't just any floods. They're the great flooding at the end of the Ice Age, when sea levels rose 120 meters and reshaped the world's coastlines. An event so catastrophic, so world-changing, that it became embedded in human cultural memory across the globe. The event that marks the transition from the Pleistocene to the Holocene, from the Ice Age to the modern world, from the world of the megafauna and vast coastal plains to the world of agriculture, civilization, and the coastlines we know today. If this interpretation is correct, it has profound implications. It means oral traditions are more reliable over longer timescales than many scholars have assumed. It means we should take these myths seriously, not as literal accounts, but as cultural memories of real events, transformed through retelling, but retaining a kernel of historical truth. And it means that the end of the Ice Age wasn't just a geological event. It was a human catastrophe, traumatic enough that our ancestors remembered it and passed the memory down for 10,000 years. What else might be preserved in these stories? Graham Hancock and other researchers have suggested that flood myths might also preserve memories of lost civilizations, advanced cultures that existed before the flooding and were destroyed by the rising seas. The stories often include details about survivors who possessed special knowledge, who taught others after the flood, who helped rebuild civilization. Are these just narrative embellishments, or do they reflect some historical reality? It's speculative, and the mainstream archaeological consensus is that there's no evidence of advanced pre-flood civilizations. But the question remains open. The lands where such civilizations would have existed, the coastal plains and continental shelves, are underwater. Archaeological investigation of these areas is expensive, difficult, and in its infancy. Most underwater archaeology focuses on shipwrecks or known historical sites. Systematic survey of drowned coastlines is rare, but when researchers do look, they sometimes find surprises. Doggerland, the landmass that connected Britain to continental Europe, has yielded tools, animal bones, and evidence of human occupation. The continental shelf off the coast of Florida has produced artifacts from habitation sites thousands of years old. Off the coast of India, structures that might be human-made have been found in water depths, suggesting they date to before the area was flooded. Each discovery raises more questions than it answers. The flood myths tell us that people were there, living on those now drowned lands. And they tell us that when the waters rose, the survivors remembered. They remembered the land that was lost. They remembered the catastrophe. And they told their children, who told their children in an unbroken chain of memory stretching from the end of the Ice Age to the present. Whether those memories include evidence of lost civilizations remains to be seen. But the memories themselves, preserved in myth and oral tradition, are evidence enough. evidence that the end of the Ice Age was experienced by our ancestors as a world-changing catastrophe. Evidence that they survived and adapted and carried forward the knowledge and stories of what came before. Evidence that we are the inheritors of a world remade by ice and water, shaped by forces our ancestors could only interpret as divine, but which we now understand as the natural consequences of climate change on a planetary scale. The deluge happened. The memories remain. And perhaps, buried beneath the waves, there are still discoveries to be made, still evidence waiting to be found of the world that existed before the flood. The world our ancestors knew and lost. The world we've only recently begun to rediscover, one submerged landscape at a time. The drowned lands to truly understand what was lost. When the Ice Age ended, we need to look at specific places, not abstractions, not statistics about millions of square kilometers or hundreds of meters of sea level rise. We need to imagine actual landscapes, real places where people lived, hunted, raised families, developed cultures, places that existed for thousands of years and then disappeared beneath the waves. Let's visit these drowned lands, one by one, and understand what the world lost when the oceans rose. Start with Doggerland. The name might not be familiar, but the place should haunt our imagination. Doggerland was a landmass that connected Great Britain to continental Europe, covering what is now the North Sea. It wasn't a narrow land bridge. It was a vast, rich territory, roughly the size of modern England, that existed from around 20,000 years ago until it was completely submerged around 500 years ago. Picture Doggerland at its peak around 12,000 years ago. A low-lying plain crossed by rivers, the Rhine, the Thames, and other rivers that today empty into the sea flowed through Doggerland, joining together before flowing north into the Atlantic. The landscape was varied. River valleys with dense vegetation, hills covered in woodlands, marshes and wetlands teeming with birds, grasslands where herds of deer and aurochs grazed, lakes formed by glacial meltwater, coastlines where seals hauled out and fish spawned. This was prime habitat. The rivers provided fresh water, fish, and transportation routes. The varied landscape offered diverse resources, game animals, edible plants, materials for tools and shelter. The climate, while cooler than today, was warming, becoming increasingly hospitable. Archaeological evidence, in the form of tools and bones dragged up by fishing trawlers from the North Sea floor, shows that humans inhabited Doggerland, probably in significant numbers. We don't know exactly how many people lived there or what their culture was like. The evidence is fragmentary, literally dredged up from the seafloor, out of context, corroded by salt water and scattered by currents. But we know they were there. Mesolithic hunter-gatherers, the same cultures that inhabited surrounding regions. They would have moved seasonally, following game and plant resources. They would have developed intimate knowledge of the landscape. They would have had territories, trade networks, social structures, beliefs, stories. And then the sea began to rise, gradually at first, so gradually that generations might pass without anyone noticing significant change. But by 8,000 years ago, Doggerland was shrinking noticeably. The rivers that once flowed through dry valleys were backing up, creating estuaries. The coastline was advancing inland from all directions. North, south, east, west. The land was being pinched, fragmented, turned from a connected plain into an archipelago of islands and marsh. By 7,000 years ago, Only a few higher hills remained above water, islands in the growing North Sea. And then, around 500 years ago, even these were gone. Doggerland was erased. The people who had lived there for thousands of years were forced to migrate to Britain, now an island rather than a peninsula, to continental Europe, now separated from Britain by a channel of water. The land bridge was severed. The North Sea existed where once there had been hills, rivers, and human communities. What was lost, we'll never fully know. But we lost archaeological evidence of thousands of years of human occupation. We lost the opportunity to understand how these Mesolithic cultures adapted to climate change, how they dealt with rising seas, how they made decisions about when to move and where to go. We lost their settlements, their art, their graves, their stories, all underwater, all buried under 20 to 40 meters of sediment in a seafloor environment hostile to preservation of organic materials. Now shift your perspective to Southeast Asia, to Sundaland, an even larger drowned landmass. During the last glacial maximum, what is now Indonesia was not thousands of islands. It was a continental extension of Southeast Asia. The islands of Sumatra, Java, Borneo, and many smaller islands were connected to each other and to the Asian mainland. The South China Sea was largely dry land. The Java Sea didn't exist. Sundaland was enormous, roughly 8 million square kilometers of land, about half the size of India. It was tropical, fertile, crossed by rivers. It would have been one of the richest environments on Earth. Tropical rainforests, river systems, coastal plains. This wasn't marginal territory. This was prime real estate for human habitation. And humans were there. Homo erectus had reached Java by 5 million years ago. Homo sapiens arrived much later, but were certainly present by 50,000 years ago, probably earlier. These populations would have expanded during the Ice Age. When Sundaland was at its greatest extent, they would have developed cultures adapted to the tropical lowland environment. They would have exploited the rivers, the forests, the coastlines. We know almost nothing about them, because when sea levels rose, Sundaland drowned. The South China Sea formed. The Java Sea appeared. The connected landmass fragmented into the Indonesian archipelago we know today, and any evidence of the cultures that existed on Sundaland went underwater. Think about the implications. Southeast Asia is considered one of the cradles of human civilization. Rice agriculture, metallurgy, maritime cultures, all developed in this region. But our understanding is based on evidence from the islands and coasts that remained above water. What about the cultures that lived in the interior of Sundaland, on the now drowned river valleys and plains? What technologies did they develop? What innovations were lost when they were forced to migrate or drowned by rising seas? Some researchers have speculated that Sundaland might have been a center of early development, possibly including plant domestication or other advances that occurred earlier than recognized because the evidence is underwater. It's speculative, but it's also logical. The best land, the most productive territories, are often the ones at lowest elevation. River deltas, coastal plains, exactly the areas that drowned when sea level rose. Consider Beringia, the land connection between Asia and North America. During the Ice Age, the Bering Strait didn't exist. Instead, there was a landmass connecting Siberia to Alaska. This is the route humans used to enter the Americas, migrating across what is now underwater, but was then a viable, inhabited landscape, Beringia wasn't just a corridor that people passed through. It was a place where people lived. Recent research suggests Beringia might have served as a refugium during the last glacial maximum, a place where human populations persisted even while ice sheets made much of the northern latitudes uninhabitable. People lived there for thousands of years, hunting mammoth and other game, developing the culture and technologies that their descendants would carry into the Americas. And then it drowned. As sea levels rose, the land connection was severed. First it became narrower, a true land bridge. Then it was breached, creating the Bering Strait. The people living there would have had to choose move west into Siberia, move east into Alaska, or stay on shrinking islands that would eventually disappear. By about 11,000 years ago, Beringia was mostly submerged. Today, the Bering Strait averages about 50 meters deep, meaning the land was drowned by the sea level rise at the end of the Ice Age. The Persian Gulf, as we've discussed, was a river valley. The Tigris, Euphrates, and rivers from the Arabian Peninsula flowed through a landscape that is now seafloor. This valley would have been extraordinarily fertile, watered by multiple river systems, supporting rich vegetation and abundant game. It would have been an ideal place for human habitation. And indeed, archaeological sites around the current shores of the Persian Gulf show evidence of sophisticated cultures in the early Holocene. But what about the sites that are now underwater in the valley itself? We can only speculate, but some researchers have suggested that the flooded Persian Gulf Valley might have been home to early developments in agriculture, animal domestication, or even urban centers. The famous ancient cities of Mesopotamia, or Uruk, Babylon, were built on the floodplains of the Tigris and Euphrates rivers after sea level rise created the Persian Gulf. But what about before? What existed in that valley when it was dry land? We don't know. The evidence, if it exists, is under 50 meters of water, buried under thousands of years of marine sediment. To find it would require systematic underwater archaeological survey of an entire sea. It's technically possible with modern technology, but it's expensive and time-consuming. So far, such surveys have been limited. Mostly, we're left with questions and speculation. Move to the coast of India. The continental shelf off the west coast of India is broad and shallow, meaning vast areas were dry land during the Ice Age. Cities and cultures of ancient India developed on the coasts as we know them today. But those coasts were established only after sea level rise. Before that, the coastline was further out, the continental shelf was inhabited land. In the Gulf of Cambay off the coast of Gujarat, underwater surveys have detected what some researchers interpret as possible structures, organized patterns that might indicate human construction. The evidence is controversial. Marine geologists have alternative explanations for the formations, but the finds have raised the possibility that significant habitation sites might exist underwater off India's coasts. Similar possibilities exist for many coastal regions around the world. The east coast of North America, the coast of China, the Persian Gulf, the Black Sea, the Mediterranean, anywhere with a broad continental shelf that was above water during the Ice Age is a candidate for drowned archaeological sites. Australia is particularly interesting. During the Ice Age, Australia, New Guinea, and Tasmania were connected, forming a larger landmass called Sahul. The coastline extended much further out than today, Aboriginal Australians arrived on Sahol at least 65,000 years ago, possibly earlier. For tens of thousands of years, they inhabited not just the areas that are above water today, but also the now drowned continental shelves. The Great Barrier Reef wasn't always a reef system separated from the coast by water. During the Ice Age, when sea levels were lower, parts of what is now reef were dry land or shallow lagoons. Aboriginal people would have inhabited these areas, exploited the resources. As sea levels rose, these territories were lost. Aboriginal oral traditions, as we've discussed, preserve memories of these changes. Stories about islands that were once connected, about hunting grounds now underwater, about the sea advancing and people having to move. These traditions, corroborated by geological evidence, show that humans were there, witnessed the drowning of the lands, and remembered. All around the world, the same pattern: coastlines drowned, continental shelves submerged, islands formed where once there were hills, straits created where once there were land connections, and everywhere human populations displaced, forced to migrate, watching their ancestral lands disappear beneath the rising waters. The scale is staggering. Estimates suggest that 20 to 25 million square kilometers of land were submerged by post-glacial sea level rise. For comparison, that's roughly equivalent to the combined area of Russia and Canada, an entire continent's worth of land underwater, and this wasn't tundra or ice-covered territory. Much of it was prime habitat. River valleys, coastal plains, tropical lowlands, the kinds of environments where human populations thrive, where food is abundant, where cultures develop, where, if you're going to find advanced early civilizations, you'd expect to find them, all underwater. If there were cities, their rubble on the seafloor. If there were monuments, their broken stones in the sediment. If there was art, it's decayed or scattered. If there were written records, they're long since dissolved. The ocean is not kind to archaeological preservation. Saltwater corrodes, currents scatter, marine life colonizes, sediments bury. What remains are fragments, tantalizing hints that something was there, but rarely enough to reconstruct a complete picture. This is why the question of lost civilizations persists. Not because there's good evidence for them, but because there's an absence of evidence that could go either way. The lands where such civilizations could have existed are underwater. Most of those lands have never been systematically surveyed. The few surveys that have occurred have found evidence of human presence, but rarely anything definitive. Absence of evidence isn't evidence of absence, as the saying goes, but nor is it evidence of presence. We're left in a frustrating limbo, unable to prove that advanced pre-flood civilizations existed, but also unable to prove they didn't. The evidence, if it exists, is buried beneath the waves. What we can say with certainty is that the drowned lands were inhabited. Humans lived on Doggerland, on Sundaland, on Beringia, in the Persian Gulf Valley, on the Sahol shelves, and on continental shelves around the world. We have the tools, the artifacts, the oral traditions. We know they were there. We also know that when the seas rose, those populations had to move. They became refugees, migrating to higher ground, to what are now the coasts and islands we know today. They brought with them their knowledge, their technologies, their stories. And they adapted to their new homes, building the cultures that eventually became the historical civilizations we study. But something was lost, territories abandoned, communities broken. landscapes drowned, and with them, the archaeological record of thousands of years of human history. The story of how Ice Age humans lived on these now submerged lands, how they adapted to the changing climate, how they dealt with the rising seas. That story is mostly gone, preserved only in fragments and oral traditions. The drowned lands represent a missing chapter in human history, a chapter written on landscapes that no longer exist, in settlements buried under the waves. We've only just begun to read the few fragments we've recovered. There's more to discover, certainly. But much has been lost forever, erased by the same rising seas that transformed the Ice Age world into the world we know today. The ocean gave us new coasts, new islands, new maritime environments, but it took entire landscapes in exchange. And with those landscapes, it took a part of our history that we'll never fully recover. The survivors, but people survived. Despite the megafauna extinctions, despite the Younger Dryas, despite the flooding of their coastlines and the drowning of vast territories, humans endured. We adapted, migrated, rebuilt. And in the early Holocene, as the climate stabilized and the catastrophic phase of sea level rise ended, we didn't just survive. We flourished. We created monuments, developed agriculture, built complex societies. The survivors of the Ice Age became the founders of civilization. To understand this transition, we need to visit one of the most extraordinary archaeological sites ever discovered, a place that challenges many assumptions about prehistoric humans and raises profound questions about what was lost and what was preserved through the Ice Age catastrophe. The place is called Göbekli Tepe, and it sits on a hilltop in southeastern Turkey, near the modern border with Syria. Göbekli Tepe was built approximately 600 years ago, right at the beginning of the Holocene, right after the Younger Dryas ended, right as the final pulse of sea level rise was drowning the coastal lowlands. The people who built it were hunter-gatherers, not agriculturalists. They didn't have metal tools, didn't have writing, didn't have domesticated animals for labor. By all conventional understanding of human cultural evolution, they shouldn't have been able to build what they built. And what did they build? Massive stone circles, T-shaped limestone pillars, some weighing over 10 tons, carved with intricate relief sculptures of animals. Foxes, snakes, scorpions, vultures, wild boars, abstract symbols, human hands. The pillars are arranged in circles, some up to 20 meters in diameter, buried deliberately after use, and then new circles built on top. At least 20 such circles have been identified, and only a fraction of the site has been excavated. The labor required to build Göbekli Tepe would have been enormous. The limestone pillars had to be quarried from bedrock using stone tools, shaped, carved with their detailed reliefs, transported, some probably requiring hundreds of people to move, erected upright and stabilized. All of this without metal tools, without wheels, without draft animals, just human muscle, stone tools, knowledge, and organization. Why would hunter-gatherers do this? What was the purpose? The site doesn't appear to be residential. No evidence of permanent habitation, no houses, no hearths for daily cooking. It seems to have been ceremonial, a gathering place, perhaps a temple or ritual center. But for people we've always assumed lived in small, mobile bands, focused entirely on survival, the construction of such a monument seems impossible, unless they weren't as simple as we assumed, unless the survivors of the Ice Age carried forward knowledge, organizational capacity and cultural sophistication that allowed them to undertake monumental construction projects, unless Göbekli Tepe represents not the beginning of civilization but a continuation, a rebuilding by people who remembered or inherited knowledge from before the flood. This is controversial, of course. Mainstream archaeology interprets Göbekli Tepe as evidence that complex social organization and monumental architecture preceded agriculture, not that it derived from some lost earlier civilization. The builders were skilled, organized, and probably had seasonal gatherings where hundreds or thousands of people came together for ceremonies, feasts, and construction work. This gathering and cooperation might have even contributed to the later development of agriculture, as people living in close quarters would have intensified their exploitation of wild plants and animals, eventually leading to domestication. But the timing is striking. Göbekli Tepe was built right at the transition from Ice Age to Holocene. Right when the floods were drowning the coastal lowlands, right when populations displaced by rising seas would have been migrating inland, seeking new territories, perhaps bringing with them knowledge and traditions from their lost homelands. Is it possible that the builders of Göbekli Tepe included refugees from the drowned coastlines, people who had lived in the fertile river valleys and coastal plains that were now underwater? People who carried forward cultural knowledge, astronomical understanding, organizational skills learned in their previous homes. We can't prove it, but we also can't rule it out, and Göbekli Tepe isn't alone. Around the same time period, 12,000 to 10,000 years ago, other sites in the Fertile Crescent show evidence of increasing complexity. Sedentary or semi-sedentary villages, grain storage, early domestication of plants. The transition to agriculture is traditionally dated to around 10,000 years ago, developing in this region and then spreading. But why here? Why at this time? The standard explanation is environmental. The Fertile Crescent has wild ancestors of wheat, barley, lentils, and other crops. It has a climate suitable for early agriculture, and the Younger Dryas hardships might have pushed people toward cultivation as wild resources became less reliable. All of this is plausible and supported by evidence. But there's another factor rarely discussed. The Fertile Crescent is inland, elevated above the coastal plains that were flooded. It would have been a destination for refugees from the drowning lowlands, populations moving inland from the Persian Gulf as it flooded, from the Levantine coast as sea levels rose, from river valleys in Mesopotamia as they became estuaries. These people, displaced by environmental catastrophe, would have brought their knowledge, their experience, their cultural traditions to the highland regions where agriculture developed. Did they bring with them nascent agricultural knowledge, an understanding of plant cultivation developed on the coastal plains, but lost when those plains drowned? Or did the crowding of populations in the remaining habitable regions create the pressure and opportunity for agricultural innovation? Again, we can't know for certain, but the correlation between the flooding of the coasts, the migration of populations, and the sudden appearance of agriculture and monumental architecture in the Fertile Crescent is at least suggestive. Look at other regions around the world. Agriculture developed independently in multiple places: Mesopotamia, China, Mesoamerica, South America, Sub-Saharan Africa, New Guinea. Each developed its own suite of domesticated crops, suited to local conditions. and in many cases, this development happened in the early to mid-Holocene, the period from 11,000 to 6,000 years ago, the same period when sea level rise was completing its transformation of the coastlines. Is this coincidence? Perhaps agriculture was an idea whose time had come, a response to climate stabilization and population pressure that would have happened regardless. Or perhaps the disruptions caused by climate change and flooding accelerated cultural evolution. Displaced populations concentrated in shrinking territories, forced to innovate or starve. Knowledge preserved from drowned regions, applied in new contexts, the survivors adapting, creating new ways of life to replace what was lost. Consider China. The Yellow River and Yangtze River valleys became centers of early Chinese civilization, with rice and millet agriculture developing by 10,000 to 9,000 years ago. But what about the coastal plains of eastern China? During the Ice Age, the coastline was much further east. The Yellow Sea was largely dry land. Populations would have lived there. And as sea levels rose, they would have migrated west into the river valleys, where Chinese civilization eventually flourished. Did they bring knowledge with them? Cultural practices, early agricultural experiments. The archaeological record from the drowned coastal plains is gone, so we can only speculate. In the Americas, the picture is complex. The earliest evidence of human presence dates to before the end of the Ice Age, with populations entering via Beringia and spreading rapidly. As Beringia drowned and coastal regions around the Americas were inundated, populations adapted. On the northwest coast of North America, complex hunter-gatherer societies developed, with permanent villages, social hierarchies, art traditions, all without agriculture. In Mesoamerica and South America, agriculture developed independently, with maize domestication in Mexico, potato domestication in the Andes, and various other crops. The survivors in the Americas faced different challenges than those in the Old World. No megafauna to domesticate. The horses and camels having gone extinct. Fewer large mammals suitable for agriculture, but they adapted brilliantly, developing agricultural systems suited to their environments and eventually building civilizations that rivaled anything in Europe or Asia. And they did this while also dealing with the flooding of their Ice Age coastlines, the loss of territories to rising seas, the migration and adaptation required by climate change. Everywhere the same pattern. Survival, adaptation, innovation. The end of the Ice Age was catastrophic, but it wasn't the end of humanity. We survived, and within a few thousand years of the climate stabilizing, we had transformed from small bands of mobile hunter-gatherers into sedentary villagers, farmers, builders of monuments and cities. The Neolithic Revolution, as it's called. The foundation of everything that came after, including the civilizations we know from history and the globalized world we live in today. But was it truly a revolution, a sudden break with the past? Or was it a recovery, a rebuilding, by survivors who carried forward knowledge and cultural sophistication from the Ice Age? The question matters because it affects how we understand human history. If complex societies only began with agriculture 10,000 years ago, then the previous tens of thousands of years of human existence were a long prologue, with the real story beginning in the Holocene. But if complex societies existed before, on the now drowned coastlines, then the Holocene isn't a beginning. It's a continuation, a rebuilding after catastrophe. The evidence is ambiguous. We have geologically tip, a monument that seems impossibly sophisticated for hunter-gatherers. We have the rapid development of agriculture in multiple regions shortly after the flooding. We have flood myths suggesting cultural memories of lost lands and lost knowledge. We have oral traditions claiming that civilization was taught by survivors or culture heroes after a great catastrophe. But we don't have definitive proof of pre-flood civilizations. The lands where they would have existed are underwater, and underwater archaeology has barely scratched the surface. What we can say is that the people who survived the end of the Ice Age were resilient, innovative, and capable. They faced environmental catastrophes that would challenge even modern societies: rapid climate change, megafauna extinctions, volcanic eruptions, rising seas drowning their homelands. And they survived, they adapted, they learned, and they built the foundation for everything that came after. Whether they were starting from scratch or rebuilding on the ruins of something lost, they were remarkable. The monuments they built, like Göbekli Tepe, the agricultural systems they developed, the societies they created, all testify to human ingenuity and perseverance. We are their descendants. We inherited their world, the world they reshaped through the catastrophes of the Ice Age ending. And perhaps we also inherited some of their knowledge, passed down through generations, embedded in our cultures, our myths, our understanding of the world. The survivors left us more than just genes and artifacts. They left us a legacy. The agricultural crops we still eat today, domesticated thousands of years ago. The animals we live with, descended from those first domesticated species. The monumental architecture that inspired later temples and cathedrals. The flood stories that still resonate in our myths and religions. And perhaps, most importantly, they left us the example of survival itself. The proof that humans can face catastrophic change, and not just endure, but thrive, creating something new from the wreckage of what was lost. The Ice Age ended, the world transformed, the giants died, the coastlines drowned, but humans survived, and in the aftermath, in the early Holocene, those survivors built the foundation of civilization. Whether they were building something entirely new or rebuilding something lost, they succeeded, and we are here because of them, living in a world they made possible, inheritors of their resilience, their knowledge, and their will to survive, no matter what catastrophes nature throws at us. What was lost? Let's be honest about what we don't know. Let's acknowledge the gaps in our understanding, the missing pieces of the puzzle, the questions we may never be able to answer. Because when the ice ages ended and the seas rose, we didn't just lose land. We lost evidence. We lost context. We lost the ability to fully understand our own history. Think about what archaeology requires. You need sites, physical locations where people lived, worked, died. You need artifacts, the things they made and used. You need organic remains, bones, seeds, charcoal that can be dated and analyzed. You need stratigraphy, layers of soil and sediment that preserve the sequence of occupation and activity. You need context, the relationship between objects and features that allows you to interpret what happened. And you need these sites to be accessible on land or in shallow water that can be surveyed, preserved well enough that something recognizable remains, not too deeply buried, not too badly degraded, not scattered beyond reconstruction. Now consider what happened to the Ice Age coastlines. They're underwater, 20 to 120 meters below current sea level, depending on location, covered by marine sediment that's been accumulating for 7,000 to 15,000 years, subjected to waves, currents, storms, tides, colonized by marine life, corroded by salt water. Any organic materials, unless preserved in exceptional conditions, are long gone. Wood decayed, textiles dissolved, leather and hide rotted, even bone, unless in very specific environments, deteriorates in seawater. What might remain? Stone tools, possibly, if they haven't been scattered. Stone structures, maybe, if they were substantial enough and haven't been broken up by geological processes. Ceramics, which preserve better than organics, but can still be broken and scattered. Shell middens, the garbage heaps of coastal peoples, which might preserve under the right conditions, but all of it buried, degraded, out of context, extraordinarily difficult to find and interpret. This means that an enormous portion of the archaeological record from the Ice Age is effectively lost. Not just lost in the sense that we haven't found it yet, but lost in the sense that it may be impossible to find, or, if found, impossible to interpret meaningfully. The best lands, the places where human populations would have been most dense, where cultures would have been most developed, were the coastal plains and river valleys, the places that are now underwater. So when we talk about Ice Age humans, our understanding is based on what? On inland sites, caves, because they provide shelter and preserve evidence well. High ground that stayed above water. Interior regions away from the coasts. These sites give us valuable information, certainly, but they're not representative. They're the margins, the hinterlands. The main stage, the coastal plains where the action was, is gone. Imagine future archaeologists trying to understand modern human civilization, but they can only excavate mountain sites. They find ski resorts, hiking shelters, mining towns. From these, they reconstruct human society. They conclude we were a culture that valued high altitudes, that built structures oriented towards skiing, that extracted minerals from rock. They miss the cities, the agricultural heartlands, the coastal ports, the industrial centres, all the really important stuff, drowned by some catastrophe and buried under sediment. Their reconstruction of our civilization would be wildly incomplete and probably misleading. This is the situation we're in regarding Ice Age humans. What specifically was lost? Let's catalogue the possibilities, acknowledging that much of this is speculation, but informed speculation based on what we know about human behaviour, environmental preferences, and the few glimpses we've had of the drowned lands. As population centres, our humans prefer to live near water, rivers, lakes, coasts. These provide food, transportation, fresh water, diverse resources. The richest archaeological sites from later periods are often located in these environments. The same would have been true in the Ice Age. But Ice Age coastlines, river deltas, and lake shores in many regions are now underwater. The population centres, if they existed, are gone. Maritime cultures. Humans have been seafaring for a very long time. Australia was reached by sea at least 65,000 years ago, requiring boats capable of crossing significant water gaps. If Ice Age humans had sophisticated boat technology, evidence of it would most likely be found in coastal sites. But those sites are underwater. We might be massively underestimating the maritime capabilities of Ice Age peoples because all the evidence is inaccessible. Early agriculture is traditionally dated to about 10,000 years ago, developing in the Fertile Crescent. and then spreading. But what if plant cultivation or manipulation began earlier on the coastal plains that are now drowned? The wild ancestors of many crops grow in lowland and coastal environments. Early experiments with cultivation could have occurred there, and the knowledge might have been preserved and formalized after the flooding forced people to move inland. We'd never know because the evidence is underwater, as advanced technology. Stone tools are what survive best in the archaeological record, but stone tools are only a fraction of human technology. Wood, fibre, bone, leather, these were equally important and probably more commonly used for many purposes. A sophisticated wooden tool culture would be almost invisible archaeologically, especially in underwater environments. If Ice Age humans developed advanced technologies using perishable materials, we might never find evidence. As art and symbolic culture, as we have some Ice Age art, cave paintings in Europe, carved figurines, engraved objects, these are extraordinary and show that Ice Age humans had sophisticated symbolic and artistic capabilities. But how much more art existed in forms that didn't preserve? Paintings on wood or hide, textiles with woven patterns, body art, music and dance traditions, oral literature, all gone, leaving only the fragments that happen to be preserved in caves or buried in dry conditions. Social organization. Seven says, how were Ice Age societies organized? We assume small mobile bands of hunter-gatherers, but this assumption is based partly on ethnographic analogy with modern hunter-gatherers who often live in marginal environments, and partly on archaeological evidence from inland sites. Coastal hunter-gatherers, both historical and modern examples, can have much more complex social organization. Permanent villages, social hierarchies, specialized roles, trade networks. If Ice Age coastal populations had this complexity, the evidence is drowned. Knowledge systems. What did Ice Age humans know? About astronomy, navigation, natural history, medicine, engineering. We know they were keen observers and had detailed knowledge of their environments. But how sophisticated was this knowledge? Did they have systematic understanding of the stars, the tides, the seasons? Did they have oral encyclopedias of plant and animal lore? Mathematical or geometric concepts? We'll never know what knowledge systems were lost when the populations that held them were displaced or destroyed by the flooding. Languages. Thousands of languages have been spoken by humans over our history. Most have left no trace. A language spoken by coastal populations 15,000 years ago, who were then wiped out or displaced by rising seas, is gone forever. We can't reconstruct it, can't know what it sounded like, can't access the concepts and categories it used to understand the world. And with languages go entire ways of thinking, cultural knowledge embedded in vocabulary and grammar, spiritual and religious systems. As Ice Age humans had belief systems, rituals, concepts of the sacred and the profane, we glimpse this in their art, their burial practices, their apparent ritual sites. But what were the details? What gods or spirits did they revere? What myths explained their world? What ceremonies marked the seasons, births, deaths, transitions? Some of this might be preserved in the traditions of descendant populations transformed beyond recognition, but much is lost entirely. The everyday. We focus on the spectacular, monuments, art, dramatic events, but most of human life is mundane. Daily routines, conversations around fires, children playing, meals prepared and shared, disputes and reconciliations, all the texture of lived experience, the details that make a culture real and human. Almost none of this preserves archaeologically, and for Ice Age coastal populations, even the unusual stuff didn't preserve because it's underwater. The frustrating thing is that we occasionally get glimpses of what's missing, a particularly well-preserved site that shows unexpected complexity, an artifact that indicates technology we didn't know existed, an oral tradition that, when investigated, turns out to have a kernel of historical truth. These hints suggest that there's much more to the story than we currently know, but they're just hints. Fragments, not enough to reconstruct the full picture, and there's a cognitive bias at play. It's easy to dismiss what we haven't found as never having existed. We have no evidence of X, therefore X didn't exist. But absence of evidence isn't evidence of absence, especially when the places where evidence would be found are underwater and largely unsurveyed. The archaeological record is not a complete census of past human activity. It's a biased sample, skewed toward what preserves well, what happens to be inaccessible locations, and what we happen to have found so far. This doesn't mean we should believe every speculative theory about lost civilizations or advanced prehistoric technology. Evidence matters, but it does mean we should be humble about the limits of our knowledge. There's a difference between saying, "We have no evidence for this," and "This definitely didn't exist." The former is honest acknowledgement of ignorance. The latter is overconfidence based on incomplete information. What was lost when the ice ages ended? We lost land, territory, ecosystems. We lost animal species, the megafauna that had been humanity's companions and competitors for hundreds of thousands of years. We lost landscapes, the vast coastal plains and river valleys that supported human populations. And we lost knowledge, the accumulated wisdom of Ice Age peoples, their understanding of their world, their technologies, their cultures, their stories. Some of this was preserved, passed down by survivors, adapted to new circumstances. The crops we eat, the animals we live with, the languages we speak, the myths we tell, all have roots extending back through the catastrophes of the Ice Age ending. But much was lost entirely, gone without a trace, or buried so completely underwater that we'll never recover it. This is the tragedy of the drowned lands, not just that they're physically gone, but that with them went a chapter of human history we can never fully read. We're left with questions, speculation, and the knowledge that our ancestors lived through extraordinary times and that most of their story is lost to us forever. The ocean keeps its secrets, and some of those secrets are pieces of our own past, drowned beneath the waves when the Ice Age ended and the world transformed. The complete picture. Let's step back. Let's try to see the entire sweep of events, the full picture of what happened when the Ice Age ended. Not the individual details, the specific sites, the particular debates, but the big story. The transformation of Earth and the human experience of living through it. 20,000 years ago, the world was in the grip of the last glacial maximum. Ice sheets kilometers thick covered Canada, much of the northern United States, northern Europe, and parts of Asia. Mountain glaciers mantled the Andes, the Himalayas, the Alps, the Rockies. Antarctica was larger, Greenland was larger, and sea levels were 120 meters lower than today. The coastlines were far out from where they are now. Vast areas of continental shelf were exposed land, supporting grasslands, forests, rivers, and human populations, the climate was colder, drier, windier. The atmospheric circulation was different, with the jet streams shifted by the presence of the ice. Deserts expanded. Tropical rainforests contracted. The mammoth steppe, a cold grassland ecosystem, unlike anything that exists today, stretched from France to Canada. This was a world dominated by ice, and humanity was adapted to it. We were Ice Age specialists, skilled at surviving in cold environments, hunting the megafauna that thrived on the glacial steppes and tundras. And then it changed. Around 15,000 years ago, perhaps triggered by subtle shifts in Earth's orbit, perhaps by feedback loops in the climate system, the warming began. Not everywhere at once, not uniformly, but globally the trend was toward warmth. Ice sheets started to melt. Meltwater poured into the oceans. Sea levels began to rise. The climate oscillated, with advances and retreats, but the overall direction was clear. The Ice Age was ending. For humans, this was experienced as a changing world. Game migrations shifted. Plant communities moved. Coastlines began their slow advance. For those living on the coastal plains, the changes might have been imperceptible at first. But generation after generation, decade after decade, century after century, the waters rose. Hunting grounds were swamped. Villages had to be relocated. Over a lifetime, you might watch the ocean advance kilometers inland. Over many generations, entire landscapes disappeared. Around 12,900 years ago, something happened, the Younger Dryas. A return to Ice Age cold in the middle of the warming. For Fun's 200 years, temperatures plummeted. Glaciers advanced again. Conditions became harsh. This was a test of survival, a climate whiplash that stressed every living thing. Humans persevered, but it wasn't easy. Populations declined. The megafauna, already stressed by the earlier warming, declined further. And then, 700 years ago, the Younger Dryas ended. The warming resumed even more rapidly than before. This was the final transition. The Holocene began. The modern interglacial period. Within a few thousand years, the great ice sheets melted completely. North America's Laurentide ice sheet, which had persisted for tens of thousands of years, vanished. Europe's Fennoscandian ice sheet disappeared. The climate stabilized into the warm, relatively stable pattern we've known for the last 700 years. But the transition was catastrophic. The melting of the ice sheets caused sea levels to rise in pulses. Meltwater Pulse 1A around 14,000 years ago. Meltwater Pulse 1B around 500 years ago. Between them, meters of sea level rise in just centuries, flooding coastal lowlands around the world. By 7,000 years ago, sea levels had risen to within a few meters of modern levels. The transformation was complete. The Ice Age coastlines were drowned. Doggerland was gone. Sundaland was fragmented into islands. Beringia was severed. The Persian Gulf existed where once there had been a river valley. And the megafauna, the giants of the Ice Age, went extinct. By 10,000 years ago, most were gone. Mammoths, mastodons, ground sloths, saber-toothed cats, dire wolves, short-faced bears, giant beavers, woolly rhinos, cave bears. Gone. Whether killed by humans, killed by climate change, or killed by some combination, they disappeared. The ecosystems they had shaped were transformed in their absence. The grasslands they had maintained turned to forests. The world became emptier, quieter, with fewer of the massive animals that had dominated the Pleistocene. For humans, all of this, the flooding, the megafauna extinctions, the climate changes, was experienced as catastrophe. Lives disrupted, populations displaced, entire ways of life made obsolete. If you were adapted to hunting mammoth on the cold grasslands, and the grasslands turned to forest, and the mammoths went extinct, you had to change or die. If your people had lived for generations on a fertile coastal plain, and that plain was drowned by rising seas, you became refugees, seeking new lands in a world that was already occupied. The archaeological record shows evidence of this disruption. Population declines in some regions. Abandonment of sites, changes in tool technologies, subsistence strategies, settlement patterns. The end of the Ice Age wasn't a smooth transition. It was traumatic. People suffered, cultures were lost, knowledge was forgotten, but humanity survived, and remarkably, within just a few thousand years of the climate stabilizing, we didn't just recover, we transformed. By 10,000 years ago, agriculture was beginning to develop in the Fertile Crescent. By 9,000 years ago, it was spreading and being independently invented in other regions. By 6,000 years ago, complex societies with cities, writing, metallurgy were emerging. The Neolithic and then the Bronze Age. The foundation of historical civilizations, Egypt, Mesopotamia, the Indus Valley, China, all of it developed in the early to middle Holocene, in the aftermath of the Ice Age catastrophes. Was this development entirely new, humans starting from scratch after the flood? Or was it a rebuilding, a recovery of knowledge and social complexity that had existed before, but was disrupted by the flooding? The debate continues. But what's clear is that the survivors of the Ice Age ending were capable, innovative people who built the foundation for everything that came after. The flood myths, the stories found in cultures around the world, make sense in this context. They're not describing a single, literal, worldwide flood that covered the highest mountains. They're cultural memories of the sea level rise, transformed through thousands of years of oral transmission. The core is true. There was a world before a flood came, and a few survived to build the world after. The details have been mythologized, but the event itself was real. This is the complete picture. The end of the Ice Age was a period of dramatic environmental change that reshaped Earth's surface, transformed ecosystems, caused the extinction of much of the megafauna, and posed severe challenges to human populations. We survived, but at a cost. Territories lost, lives disrupted, knowledge and cultures erased, and in the aftermath, the survivors built new societies, adapted to new environments, and became the ancestors of all humans alive today. We live in the world created by these events. The coastlines we know, established when sea levels stabilized 7,000 years ago, the climate we experience, the warm interglacial that has persisted for 11,700 years, the ecosystems we inhabit, shaped by the extinction of the megafauna and the expansion of forests, grasslands, and deserts into their modern configurations. The agricultural systems we depend on, domesticated in the early Holocene. The cities we build, descended from the first settlements that grew into urban centers after agriculture provided surplus food. Everything traces back to this period. The end of the Ice Age was the hinge point between the Pleistocene, the epoch of ice and giants, and the Holocene, the epoch of agriculture and civilization. We are Holocene creatures. Our civilizations, our cultures, our ways of life, all developed in the warm, stable climate of the last 11,700 years. We have no memory, either cultural or genetic, of how to live in a true Ice Age. The world of 20,000 years ago would be alien to us, and we would struggle to survive in it. But our ancestors did survive through the transition, through the catastrophes, through the loss of their ice age world, and they remembered in myths and oral traditions, in the knowledge systems they preserved, in the way they rebuilt their societies. They carried forward what they could from the world before and used it to create the world after. We are their inheritors. The languages we speak, descended from Ice Age languages we can never reconstruct. The stories we tell, some containing echoes of events 10,000 years old. The crops we eat, domesticated by survivors shortly after the flooding. The tendency to build monuments, possibly inherited from pre-flood cultures that we glimpse in Geo-Beckley Tip. The complete picture is one of catastrophe and survival, of a world transformed and a species that adapted, of loss and rebuilding. The Ice Age didn't just end. It was ended by catastrophic climate change, by the melting of ice sheets and the rising of seas, by the extinction of ecosystems and the displacement of populations. And in the wake of these catastrophes, the survivors created something new, or perhaps recreated something old. We don't know for certain, and we may never know. What we do know is that we're living in the aftermath. 11,700 years after the Younger Dryas ended. 7,000 years after sea levels stabilized. 10,000 years after the last mammoths disappeared from most of their range. We're not Ice Age people. We're Holocene people, and the Holocene itself is a consequence of the Ice Age's ending. The world we know exists because the ice melted, the seas rose, and the survivors rebuilt. That's the complete picture. Not simple, not neat, not entirely knowable, but true in its essentials. The Ice Age ended. The world changed. Humans survived. And here we are, 11,000 years later, trying to understand what our ancestors lived through, what they lost, and what they preserved for us. Still dealing with the consequences of events that happened before recorded history, before writing, before cities. Events that shaped the world we inherited and the people we became. The Ice Age ending is not ancient history in the sense of being irrelevant. It's the origin story of the modern world, the creation myth that happens to be true, the catastrophe that reset human civilization and forced our ancestors to rebuild, and the knowledge that it happened once means it can happen again. Climate changes catastrophically, and when it does, humans are forced to adapt or die. We adapted. We survived. But we lost much in the process, and we're still discovering what was lost, one drowned landscape at a time. Modern implications: why does any of this matter today? Why should we care about events that happened thousands of years ago, about drowned coastlines and extinct megafauna and flood myths? Because the past is not past, it's prologue. What happened at the end of the Ice Age is happening again in reverse and accelerated, and understanding what our ancestors went through might help us understand what we're facing now. Today, we're living in an interglacial period that has lasted 11,700 years. The Holocene, a period of remarkable climate stability that allowed human civilization to flourish. Agriculture, cities, writing, technology, all developed during this relatively brief window of stable, warm climate. We take it for granted, but it's an anomaly. For most of the last 2 million years, Earth has been colder. Ice ages are the norm. Interglacials are the exceptions, and interglacials don't last forever. Based on past patterns, we should be heading back toward an ice age at some point in the future. The orbital cycles that trigger ice ages are still operating. In a few thousand years, or maybe tens of thousands, the next glaciation might begin. Ice sheets would grow again. Sea levels would fall. The continental shelves would be exposed once more. The world would cool, and humanity would have to adapt to living in ice age conditions again. But that's not what's happening. Instead, the climate is warming rapidly due to human activities, primarily the burning of fossil fuels and the release of greenhouse gases. We're adding carbon dioxide to the atmosphere faster than at any time in at least the last 800,000 years. The planet is responding. Temperatures are rising. Ice is melting, and sea levels are beginning to rise again. This is where the ice age ending becomes relevant, because what's happening now is, in some ways, a replay of what happened then, just much faster. At the end of the ice age, ice sheets melted over thousands of years. Today, the Greenland and Antarctic ice sheets are losing mass on timescales of decades. Back then, sea levels rose at rates of centimeters per year during the most rapid pulses. Today, sea levels are rising at millimeters per year, but accelerating. If the ice sheets collapse, as they did during meltwater pulses 1A and 1B, the rate could increase dramatically. The drowned lands of the ice age offer a preview of what could happen to our modern coastlines. Hundreds of millions of people today live in coastal areas less than 10 meters above sea level. Major cities: Miami, New York, Shanghai, Mumbai, Jakarta, Lagos, Bangkok, all vulnerable to sea level rise. Even a meter or two of rise over the next century would displace millions, cause trillions in economic damage, force massive adaptation efforts. And if warming continues unchecked, if the ice sheets do collapse, we're talking about meters of sea level rise. Possibly many meters over centuries. Coastal plains would be drowned, just as they were at the end of the Ice Age. The maps would have to be redrawn. Nations would lose territory. Climate refugees would number in the hundreds of millions, seeking new homes in a world that's already crowded and stressed. The end of the Ice Age shows us what this looks like. The disruption, the displacement, the conflicts as populations are forced to migrate, the loss of territories, cultures, knowledge. Yes, humanity survived, but at great cost. And we survived when the global population was measured in millions, not billions, when there were vast empty territories to migrate into, when there were no nation states with borders and immigration controls. The world today is far more crowded, far more organized, and in some ways far more fragile. There's another lesson from the Ice Age ending. Climate can change rapidly. The Younger Dryas showed that the system can flip from warm to cold in decades. The end of the Younger Dryas showed it can flip back just as fast. These weren't gradual transitions. They were abrupt. And they were driven by mechanisms like changes in ocean circulation that we know can be triggered by melting ice and warming temperatures. Today, scientists worry about similar tipping points. The collapse of the Atlantic meridional overturning circulation, the current system that includes the Gulf Stream. The loss of Arctic sea ice, which could trigger feedback loops accelerating warming. The thawing of permafrost, releasing massive amounts of methane and carbon dioxide. The disintegration of Antarctic ice shelves, allowing glaciers to flow faster into the sea. These are potential tipping points, mechanisms by which gradual warming could trigger abrupt, catastrophic changes. We don't know exactly where these tipping points are, or how quickly they might be crossed. but the Ice Age record shows us they exist. Climate isn't always smooth and gradual. Sometimes it jumps, and when it does, the consequences can be devastating. Our ancestors lived through the Younger Dryas, but they had time to adapt gradually because they weren't dependent on complex global systems. We are. Our food production, our energy systems, our economies all depend on stability and predictability. Abrupt climate shifts could be catastrophic. The megafauna extinctions also offer lessons. We're currently living through the 6th mass extinction in Earth's history. Species are disappearing at rates not seen since the end of the Cretaceous, when the dinosaurs died out. The causes are multiple habitat destruction, pollution, overhunting, climate change, but the result is the same: a massive loss of biodiversity. The disappearance of species that had existed for millions of years. The Ice Age extinctions show us what this means long term. Ecosystems transformed, functions lost, a world made emptier. When the megafauna disappeared, the grasslands they maintained turned to forests in some regions, changed the fire regimes, altered carbon storage. The effects rippled through the entire biosphere. The extinctions we're causing today will have similar long-term consequences. Effects we can't fully predict, but which will persist for thousands or millions of years. And yet, there's also hope in the Ice Age story. Humans survived, more than survived. We adapted, we innovated, we rebuilt. The survivors of the Ice Age catastrophes created agriculture, developed complex societies, built the foundation for all modern civilization. We're a resilient species. When faced with existential challenges, we can rise to meet them. The question is whether we'll learn the lessons before the catastrophe rather than after. Our ancestors had no choice but to react to climate change they didn't cause and couldn't control. We have the advantage of foresight. We know what's happening. We understand the mechanisms. We can see the future impacts if we continue on our current path. And we have the technological and organizational capacity to change course, to reduce emissions, to adapt to the changes that are already locked in. The drowned lands remind us of what's at stake. Not just land and property, but history, culture, knowledge. When coastlines are flooded, what's lost isn't just real estate. It's archaeological sites, cultural heritage, communities that have existed for generations. It's connections to place, to ancestors, to the past. The people displaced by sea level rise will be losing their homelands, just as Ice Age populations did. And future generations will look back at what was drowned and wonder what we lost. But understanding the past also helps us prepare. Archaeology of the drowned lands shows us that underwater sites can preserve evidence, can tell us stories about the people who lived there. Oral traditions demonstrate that cultural memory can persist for thousands of years. Flood myths show us that traumatic events become embedded in culture and passed down. If modern coastlines are drowned, the memories will persist. The stories will be told. Future humans will look back at our time and ask what we knew, what we did, and why we didn't do more. The Ice Age ending is also a reminder that Earth's climate is dynamic. It changes. Sometimes gradually, sometimes abruptly, sometimes in response to subtle astronomical factors, sometimes in response to massive perturbations like ice sheet collapses or asteroid impacts or, today, human greenhouse gas emissions. We're not separate from the climate system. We're part of it. And we're now a major driver of it. This is new. Never before in Earth's history has a single species had the capacity to alter global climate. We're conducting an unprecedented experiment on the only planet we have. The Ice Age ending shows us one possible outcome: catastrophic change, mass extinctions, reshaping of the entire surface of the planet. We survived last time. We might survive again. But survival isn't the same as flourishing, and the cost of adaptation after catastrophe is far higher than the cost of prevention before. The modern implications of the Ice Age ending are clear. Climate changes, sometimes catastrophically. When it does, civilizations are disrupted, populations are displaced, and much is lost. We can't stop change entirely, but we can influence how much and how fast. We can learn from the past, understand the risks, and make choices that minimize harm, or we can ignore the lessons, continue on our current path, and force our descendants to become refugees and survivors just as our Ice Age ancestors were. The choice is ours. The Ice Age ending happened to our ancestors. They had no control over it. Climate change today is happening because of us. We have control. What we do in the next few decades will determine how severe the impacts are, how much is lost, and whether future generations will look back at us as wise ancestors who learned from the past, or as the generation that knew the risks and chose catastrophe anyway. The drowned lands are a warning. The flood myths are a memory. The survivor's resilience is an inspiration. But the real lesson is simpler care about the future, understand the past. Make choices today that won't force our descendants to live through the catastrophes our ancestors endured. Because we know what happens when ice melts and seas rise. We've seen it before, and we don't want to see it again. We are the last picture yourself standing on a beach at dawn. The waves roll in gently, rhythmically, as they have for thousands of years. The sand beneath your feet is smooth, unmarked except for the tracks of shorebirds searching for food at the water's edge. The horizon stretches out endlessly, water meeting sky in a perfect line. It's peaceful, timeless, a scene that could have been witnessed at any point in human history. But if you could see through time, you'd know that this beach didn't exist 15,000 years ago. The place you're standing was far inland then, perhaps tens of kilometers from the Ice Age coastline. That old coastline is underwater now, drowned beneath the waves you're watching. And if you could walk out onto the continental shelf, down into the depths, you might find evidence of those who lived there. Tools scattered on the seafloor, shell middens buried under sediment, the traces of lives lived on lands that no longer exist. We are the last to live in the world as it was. The Ice Age ended 700 years ago, but its legacy persists. The coastlines we know, the climate we experience, the ecosystems we inhabit, all shaped by events that happened before cities, before agriculture, before written history. We're living in the aftermath, inheritors of a world transformed by catastrophe and rebuilt by survivors. And we are, in a very real sense, the last generation of the Holocene as it was. The stable climate that has persisted for 700 years is changing. The world our ancestors built, the civilizations they founded, were all constructed in this narrow window of stability. What comes next is uncertain. We're writing a new chapter in Earth's climate story. One way or another, the world our descendants inherit will be different from the one we've known. This is both sobering and profound. We stand at a hinge point in history much as our ancestors did 11,700 years ago when the Younger Dryas ended and the Holocene began. They couldn't choose whether the climate would change. We can influence how much and how fast. They could only react and adapt. We have the opportunity to plan, to mitigate, to prepare. They left us a legacy of survival and resilience. What legacy will we leave to our descendants? The story of the Ice Age ending is a story about time, deep time, the kind of time that makes human lifetimes feel fleeting. Mammoths existed for 700,000 years, gone in a few thousand. Ice sheets that took tens of thousands of years to form melted in a fraction of that time. Coastlines that had been stable for millennia transformed within generations. The world we think of as permanent is actually transient, temporary, a snapshot in an ongoing process of change that operates on timescales we struggle to comprehend. And yet, human memory persists, oral traditions preserving events from 10,000 years ago, flood myths passed down for hundreds of generations, cultural knowledge encoded in stories, rituals, languages. We are time-binding creatures. We connect past to future through memory and imagination. The Ice Age survivors told their children about the drowned lands, and those children told their children in an unbroken chain, reaching across millennia to us. What stories will we tell when coastal cities are flooded, when populations are displaced, when the world transforms in response to the climate changes we've triggered? What will our descendants remember about us? Will they understand that we knew what was coming? Will they wonder why we didn't do more? Or will they tell stories about how we rose to the challenge, learned from the past, and made the hard choices necessary to minimize the harm? The Ice Age ending teaches us that Earth is a dynamic system. It changes. Species go extinct. Landscapes transform. Climates shift. Nothing is permanent. But it also teaches us that life is resilient. Humans are resilient. We've survived catastrophes before. We adapted, innovated, persevered. The survivors of the Ice Age ended up creating everything we now consider civilization. They took the fragments of their disrupted world and built something new, something that 11,000 years later has grown into the global, interconnected human society we live in today. So there's reason for hope even in the face of the challenges ahead. Not complacent hope. Not the kind of hope that assumes everything will work out without effort, but the hope that comes from understanding human capacity, the knowledge that we can face difficult circumstances and come through them. The evidence written in the archaeological record and preserved in our genes and cultures that we're the descendants of survivors. But hope has to be paired with action, understanding with response, knowledge with wisdom. We know what's happening. We understand the mechanisms. We can see the trajectory we're on. The question is whether we'll use that knowledge to change course or whether we'll continue on, forcing future generations to deal with consequences we could have prevented. The drowned lands wait beneath the waves, holding their secrets. Perhaps someday, with better technology and more resources, we'll survey them systematically. We'll find the settlements that existed there, understand the cultures that were lost, piece together the missing chapters of human history. We'll dive down to the Persian Gulf floor and find evidence of the civilizations that lived in the river valley before it flooded. We'll map Doggerland completely and understand how Ice Age Europeans lived. We'll survey Sundaland and discover what Southeast Asian cultures achieved before the sea fragmented their world. Or perhaps those secrets will remain buried forever, lost to time and tide, preserved only in the flood myths and oral traditions of their descendants. Either way, the drowned lands remind us that history is fragile. That much can be lost. That the places we think of as permanent can disappear. That the world can change in ways that erase entire landscapes and the human stories written upon them. The mammoths are gone. The megafauna that dominated the Pleistocene are extinct. We'll never see them alive, never witness a herd of woolly mammoths crossing the mammoth steppe, never watch a ground sloth pulling down branches or a saber-toothed cat on the hunt. They're lost to time, preserved only in bones and rock art, and the frozen bodies occasionally revealed by melting permafrost. Their loss reminds us that extinction is forever, that once something is gone, it's gone, that the choices we make about the species alive today have permanent consequences. But life continues. New species evolve. Ecosystems adapt. The world after the megafauna is different from the world before, but it's still full of life, still rich and complex. Humans have become the dominant large animals, filling some of the ecological roles the megafauna once occupied. We shape landscapes, alter fire regimes, affect plant and animal distributions on continental scales. We're part of the system now, influencers of ecosystems and climate. With that influence comes responsibility. The Ice Age survivors carried forward what they could from the world before. Knowledge, stories, seeds, traditions. They built the Holocene world on the foundation of their Ice Age inheritance. We're doing the same. We're inheritors of 700 years of human cultural development, of all the accumulated knowledge and wisdom of our ancestors. And we have the opportunity to pass that forward, enriched and expanded, to our descendants, or to squander it, forcing them to rebuild from fragments, as the Ice Age survivors had to do. Time moves forward. The waves continue their rhythm. The planet continues its orbit around the sun. The climate continues to change, responding to the factors that drive it. We're part of that story now, more than ever before. Our choices matter. Our actions have consequences that will echo for thousands of years. The ice we're melting today won't refreeze for millennia. The species we're driving extinct won't re-evolve. The coastlines we're drowning won't re-emerge in any time frame relevant to human civilization. We are the last to live in the Holocene as it was. What comes next is being written now, in our time, by our choices. The story of the Ice Age's ending is also the story of the beginning. The beginning of the Holocene. The beginning of agriculture and civilization. The beginning of the modern world. And perhaps, if we're wise, it can also teach us how to begin the next chapter. Not with catastrophe and loss, but with foresight and care. Not as victims of climate change, but as actors who understood the risks and chose a better path. The beach at dawn. The waves rolling in. The endless horizon. It's beautiful. It's peaceful. It's temporary. Everything is. But in that temporariness is also possibility. The possibility of change, of adaptation, of learning from the past and building a better future. The possibility that we can be ancestors worth remembering, that future generations will look back at us and see not the generation that knew and did nothing, but the generation that understood and acted, that learned the lessons of the Ice Age's ending and chose not to repeat them. We are the last, but we're also the bridge. between the world that was and the world that will be, between the Ice Age survivors who came before and the descendants who will come after, between past and future. And in that position, we have the opportunity to honour both, to remember what was lost when the Ice Ages ended, and to ensure that future losses are minimised. To learn from our ancestors' resilience, and to use that knowledge to build resilience for our descendants. The Ice Ages ended, the world transformed. The survivors rebuilt, and we are here, the latest chapter in that continuing story, still discovering what was lost, still learning from the past, still facing the challenges of a changing world, still connected to those who came before and responsible to those who will come after, still standing on beaches that didn't exist 15,000 years ago, looking out at waters that cover landscapes our ancestors knew, wondering about the future, and hoping that the choices we make today will give our descendants a world worth inheriting. The sun rises. The waves continue. Time moves forward, and we move with it, carrying the past into the future, one generation to the next, connected across the millennia by memory and hope and the simple fact of our continued existence. We are the last to live in the world as it was, and the first to shape the world as it will be. Between those two truths lies our challenge and our opportunity. The story continues, and we're writing it now.